meet like Google, then Zoom. There are
Yeah,
so many.
they
Anyway,
have not
yes,
used
yes.
that. Probably they this time they have used the WebEx.
Anyway,
WebEx.
it's
It is
all
the
right, sir.
organizers. No, it is the organizers.
Yeah, yeah. Anyway, it doesn't matter.
Yes, yes, sir.
Yes. What is the procedure now? They will handle everything, is it?
Which one, sir?
This morning session, first one.
Morning session. You are chairing on first session, sir.
Yes,
Yeah,
yes.
they will start by 9:30 only, sir.
அப்படியா?
ஆஹ்
Okay,
இப்போ
okay.
இப்போ இப்போ இருங்க யாரு இதுன்னு பாக்குறேன்.
ನಮಸ್ಕಾರ ಸರ್, ನಾನು ಸಂಜೀವ.
Namaste, sir.
Sanjeevan. Good
How are
morning.
you?
I'm fine, good sir.
So you got the link?
Yeah, I got the link finally. Yes.
So everything I have sent the first day itself the same link.
Yeah, I didn't see it very carefully. I just superficially saw it. I thought
No problem. And kindly restrict your talk to 20 minutes because the organizers are going to start by 9:30 only.
Yeah, I just called Dr. Shahi. He said in 9:15 they will start. Anyway, I'm ready, and then
you are ready. You are the. I think I have to go through the process.
Yeah, he is the first speaker.
Yeah, okay, sir. So you can handle the session, sir. First session.
Yes, yes. ಸಂಜೀವ ಹೇಗಿದ್ದೀರಿ?
ನಾನು ಚೆನ್ನಾಗಿದ್ದೀನಿ ಸರ್.
Okay, very nice seeing you after a long time.
ಸರ್, yes sir.
ನೀವೆಲ್ಲಿ ಲಕ್ನೋದಲ್ಲೇ ಇದ್ದೀರಾ ಅಲ್ಲ ಊರಲ್ಲ?
ಇಲ್ಲಿ ಲಕ್ನೋದಲ್ಲೇ ಇದ್ದೀನಿ ಸರ್. ನಾನು ಇಲ್ಲಿ ಊರಿಗೆ ಬರೋದು ಕಡಿಮೆ. ಆದ್ರೂ ಸಹ ಬಂದಿದ್ದೀನಿ. ನಾನು ಈ ವರ್ಷದಲ್ಲಿ ಸುಮಾರು 2-3 ಸಾರಿ ಬಂದಿದ್ದೀನಿ. ಒಂದ್ ಸ್ವಲ್ಪ ಮನೇಲಿ ಕೆಲಸ ಇತ್ತು, ಹೋಗಿದ್ದೆ ನಾನು.
ಸರ್, ರಾಮನ್ ಸರ್, ಇವರು he is in Lucknow, and
yes, sir.
the top lichenologist of our country today.
Yes, sir. That's why I have included him in the. We included him in the editorial board.
Yes, very good.
So I know his contributions.
Thank you,
so
sir.
we have selected him a fellow, and during that time we gave a lecture also.
Agnihotri
Memorial Award for those who but now you are fortunate enough. Now you have made a stipulation that the nominee should publish at least minimum 3 publication in Kavaka.
Okay, so I have 1 or 2 publications, but I don't know 3 I may not be having, but certainly 2 I have. I remember very well.
Okay. But during that time we didn't put that condition. Now this year selection we put that condition, and probably many people have not published 3 papers in Kavaka, so they have not applied. So now we are bringing 4 issues of Kavaka. Sir,
yes.
How is the issues? You have gone through it?
Yeah, I have gone through, sir. It's good only, sir. It's good in quality.
Professor Bhatt, sir?
Yes. I think it requires a little more improvement, sir.
Sir,
if you want to get listen to me. If you want to get the citation in any of these citation indexes, it requires it only matters the quality, and that we must really strive hard. I think this has been discussed, and we must rope in people who are publishing high quality into this.
Many people are speaking many ideas, sir, but the problem is usually we have something happened. Sir, can you hear me, sir?
Yeah, I can hear you.
So initially we approached Springer, sir. During that time, they told that the 300 numbers are not enough. And during that time, only 1 volume is coming, and they said it is not possible. Then we raised them. Now the membership is into 600.
Okay.
Now we made latter we made 2 issues per 2 volumes per year. Now we have made 4 issues per year, and
I know,
we
I
are
know.
going,
Yeah. Yes.
And slowly we are going into the Scopus index. We are trying to get. We are trying to get, because a lot of criteria are there.
Yes, yes.
Yeah, many people are say, even when we put editorial board, many people are not cooperating with the editor-in-chief. Even the section editors, some of the section editors now they have not cooperated. So the lot of burdens are there now for the editor-in-chief. So slowly we have to sort out these things, sir.
See, papers when they come,
Yes,
they
sir.
should go for rigorous revision.
Revision, and also papers are people are telling, key members are telling this and that. But thing is, nobody is submitting papers to the Kavaka.
I actually even offered in some other forum, if anyone wants to get the paper correctly, I am willing to do. But they are not coming forward.
And also, I am asking even the guest editor, much of the word for special issues. So we increase, we publish some special issues by which we got a NAS score of 5.04 now.
Okay.
So like that, we are targeting. And the people has to. Many people has to submit. That's why we made a condition that if they want to apply for fellow, they have to publish 3 papers, minimum 3 papers.
Yeah. Okay, good. That's a good plan.
Yeah.
Some sound is coming.
Yeah, some sound is coming.
But I'm happy that I could get into this today. Yesterday whole day I was not able to get in.
The same link only, sir. I am entering in the same link.
But the day before yesterday, I was very disappointed that I couldn't come to the meeting. It doesn't matter.
Which session you tried?
No. Primarily, I wanted to be in the MSI meeting.
That is a link, separate link I have sent for the general body and executive committee meeting.
Maybe I couldn't get into that.
Executive committee meeting is different and the general body is different.
No, it's okay.
Yeah.
Then some
sound is coming. இல்ல ஏதோ சவுண்ட் அங்கிருந்து வந்துட்டு இருக்கு. அங்க லைன் இப்ப சரியாயிடுச்சு. சவுண்ட் கேக்குதாங்க?
Now we don't hear. Yes.
Now we just stopped, sir.
Yeah.
So all the section editors, they have brought one issue, sir, for 3 months. Every 3 months, they are bringing the one issue. I think some problem from the organizer side.
Namaste, sir.
Hello.
Hello. Good morning.
Ashwini,
Everything okay?
I am doing good. I am doing good. How are you?
I'm fine.
You're good. Okay.
I don't know, there's sound
Yeah,
disturbance.
some sound is coming.
எனக்கு வந்து தனி ஆடியோம் காமிக்கிறது பட் it's not active.
That,
கேக்குது
இல்ல, sound from the organizer side.
connecting to audio. ரெண்டு டிவைஸ் கரெக்ட்னா இந்த என்ன சொல்றது obstruction வரும். I don't know what. எங்க சைடுல கொஞ்சம் கனெக்ஷன் இஷ்யூஸ் இருக்கு.
I don't know. Somebody, they have entering as MSI. I don't know who is MSI. Somebody has put MSI. They are not muted. Now they are on. I don't know who is that person. If you go to the participant side, one icon is coming as my MSI. From that only sound is coming.
Is it?
How could it be?
Yeah.
They're muted now.
Now they muted.
I don't have an option to mute.
And you have two connections. You are entered in two connections.
No, I haven't.
No, Sasireka 1 and 2 is.
Yeah, the other one is also. I think I muted, but I don't have an option to mute.
No, you entered in only one. Probably mobile you entered.
Huh?
Mobile also you have entered.
No, I am not.
No, you two entry.
No, I had opened 2 sessions, but not 2 entry. I don't know how. My mobile is not on.
Yes, that's the issue. You have to log in, enter into one system. One system.
I don't know how this is going, sir. I have logged in.
Mobile, you are entered in mobile.
One session 10 entered and then entered this one.
No.
But I don't know how
You have logged in your mobile and also laptop or computer like that.
No, sir. My mobile is not logged in.
And then we are getting 2 images of you.
I don't know how.
You mute it. Probably yours only giving noise.
I'll do one thing. I'll just get out of this and I'll come back.
Just mute it.
And there's no option of mute also.
Then you log out. You log out first.
Yeah, I'll log out. Yeah, I'll log out. Yeah.
Then whether we see that. It is from yours only.
I don't know how, sir, but double case of Botany. I don't know. It's very funny and eerie also. I logged in only once.
So you made all people also panic. I thought from organizer side some problem is there.
Even I was thinking like that because I logged into the laptop and I went to do that.
The problem you are making, you only made the problem.
Sir, you are telling as if I did a big crime. I have not done it.
No,
I have not done it. It's something as technically which I am not able to explain.
Okay.
Good morning, sir.
Good morning. Good morning.
Good morning, ma'am.
Good morning. Good morning.
Gayatri Hande.
Yes, sir.
Okay. Good. Sir, you are entering my MSI. You are MSI.
Yes.
You are created an ID MSI.
No, it's not for some name I gave, just.
You should not give like that, sir. It is confusing. Sir, it is
Okay.
really, it is confusing, sir. It is really confusing.
Okay, I will
You
change that.
change that this thing, sir.
All right, all
Give
right.
your personal email.
I'm ready with my presentation. Only thing is that
Sir,
they have to allow it. The host has to allow me to present.
no, somebody has to come in the hall and they will admit you or permit you.
Yeah.
Professor, but I astonished. Somebody is entering MSI. I don't know who is that. So, but Professor Bhatt has made that fake ID.
No, it's not the fake ID. The only
Then
thing
how?
is that the name you give now when you enter, when you log in,
No.
when you give your name and the email address, the name he has given MSI. That's all.
No, it is MSI. All the members, if all the members in, started using MSI, then how can we differentiate? Even I have given the personal email
Name.
only.
You can put a name that way.
No.
It is only the name that was
only I
written.
am entering.
Yeah.
I am not entering as ID. I have not changed.
Sir, I was yesterday
Hello?
suffering very
Hello, sir.
much
Am I audible?
problem for joining.
Oh, Gayatri, Dr. Gayatri, the same this thing only, this link only,
Yes, sir.
the same link.
No, sir. Yesterday afternoon session,
Ah,
I am suffering very much problem for joining.
oh, you have not joined.
Yes, sir. After 3 o'clock, I have joined.
No, I have sent all the links.
Yes, sir. I got every mail, but there is a problem.
Okay.
Yes, this due to online situation all facing.
Sir,
Yes, sir.
Jairam, but sir, now it is okay, sir. Sir, Jairam, but sir, yes, muted. Sir, Jairam, but sir, now it is okay, sir.
No, what happened yesterday?
It is a little bit confusing, sir. That's why.
No, there is no confusion. Just listen. Yesterday, I was trying to with some experts how to get into this.
Sir,
And they
MSI means how can we recognize who is coming on that line?
No. It is a meeting where I am part of MSI, sir. What you are talking?
Sir, your ID cannot be used. ID cannot be an MSI ID. No, that is the thing.
No. We will not argue on this. Listen to me. Yesterday, temporarily, I put that, and it is only for this meeting I use. It doesn't matter. Now I have changed it.
Okay, thank you, sir.
But it doesn't give any difficulty on that. It doesn't matter.
No, the thing is, morning I saw this one. That's why I am telling you, sir.
Okay, fine.
Okay.
Hello. Good morning, sir.
Hello, Devendra Patel.
Hello. I'm a student, sir.
Yeah,
Ghasidas University.
You admit, you permit the slide share of Dr. Sanjeeva Nayak.
Sir, I am audible, sir.
You are audible.
Yes.
Yeah, good morning, sir.
Good morning.
Sir, good morning, sir. Madhivanan here.
Good morning, Madhivanan. Ask a student to permit Dr. Sanjeev Nayaga's slide share.
Yeah. Bhaiya, you allow Sanjay Nayak to share his slide. Sanjeev Nayak. Yeah, good morning, sir. We can start the session.
Yeah, Professor Bhatt is there. The first speaker is there.
Okay, sir.
Professor, sir, but sir,
Yes.
kindly ask the speakers to restrict 20 minutes, sir, because they are starting late.
Yes, sir. Yes, sir.
Professor Raman, what we'll do, we will request the co-chairperson to continue the meetings because they will have the details of the speakers. Right?
No, speakers speak. I think who is chair?
Oh, you report. Thank you, sir. Thank you. Supla, sir.
Because I don't have any details about the speakers.
Sir,
Except
you have the program, no, sir. You have the program, sir.
Yeah,
We send the program to you, sir.
Okay.
Sir, actually, sir, there are three speakers,
we have
sir.
sent the program to you.
Just a minute. Hold on.
Yeah.
There are three speakers, sir, in the session. All are late lectures. The first one is Dr. Sanjeev Nayak.
Yeah.
The second one is Dr. Yogesh Joshi.
Okay.
Third one is Dr. M. Sudhakar Reddy. These three are scheduled as lead lectures.
Yeah.
So, Professor Jairam Bhatt sir can start the session now.
Yes.
As a chair.
Yeah.
And the co-chair is Professor R.V. Shukla from Bilaspur.
Okay. Now, Professor
sir can
is there, so he can start, and the speaker is also there. He can start.
Yes,
the
sir.
audience are there.
Yeah, speaker is there, and Yogesh Joshi is there, and Sudhakar Reddy I'm not seeing online. He'll be joining.
He will come online.
Okay, sir.
Okay.
Then we can start, sir, without wasting time.
Yeah.
But sir,
we can
proceed,
sir. But sir.
Yeah. Thank you very much.
And also the coordinator rapporteur is also here, so therefore we can start, sir.
Okay.
Yeah.
Sir, what? Sir, your good name, sir? Your good name?
Dr. Good morning to all the participants. And I have great pleasure to welcome all of you for this third and the last day of MSI program. And we have the three speakers, I am told today. And the first speaker is Dr. Sanjeev Nayak, Senior Principal Scientist, Mycological Laboratory, NBRI. And Dr. Sanjeev is a very close friend of mine, and he's a world authority on lichens and a leading scientist from our country today. And he has done voluminous work and first-rate lichen taxonomist he is. And with this short introduction, I request Dr. Sanjeev to give his talk. And I understand we have 20 minutes for each speaker. Yes, and kindly restrict the timings. Thank you. And I request Dr. Sanjeev. Dr. Sanjeev, please.
Yeah. Very good morning to you all. Respected Chair, Dr. Bhatt sir, Secretary Raman Saab, and all the dignitaries of MSI and the participants. Can you all see my slide?
Yes, we can see, sir.
Yeah. So, as you all know, under lichen, I work on different aspects, but especially my interest is lichen taxonomy, especially revisionary work, as well as floristic work. For the today's talk, I have selected a topic where I work for. I'm working since a few years in the Manipur for inventorizing the lichen flora of that state. So the title is Current Status of Lichen Diversity in Manipur. Next, how it moves. Okay. So as you all know, lichen is a symbiotic association. I'll not go into the basic definition, but it is essential to know that lichens are no more a combination of two organisms. Of course, there is a combination of two organisms. One is primary symbiont mycobiont, that is fungal part. One is photobiont. So apart from these two primary symbionts, there are many other microorganisms are closely associated with lichens. It may be another lichen, another fungi living on the lichens, the one fungi living inside the lichen, and there may be bacteria, actinomycetes, and many other organisms are closely associated with the lichens. That is why the definition of the lichen has changed now. So it is the now it is the micro ecosystem. So Hawksworth and Grove defined recently that lichen is a self-sustaining ecosystem formed by an interaction of an exhabitant fungus and an extracellular arrangement of one or more photosynthetic partner and an intermediate number of other microscopic organisms. So this is a latest definition, but still definition is is changing because our understanding towards the association is changing, improving day by day. So then if you see the diversity of lichens worldwide, different people have given different estimate during the different time. But overall, you can say that at a given point of time, there are 20,000 species of lichens are there. So these 20,000 species of lichens we are telling since many years. Now there is a need for updating this checklist also. Of course, since it is a world checklist and there are so many changes involved, it will be a Herculean task. But still, we can say that there are 20,000 species of lichens in the world. But if you see the diversity where it is more, especially certainly it is lichen diversity is more in the tropical rainforest, and sometimes you can get up to 600 species per hectare. So this is the estimate, and sometimes you'll get more number of lichens than the tree or bird species in a given area of a tropical jungle. So, but unfortunately, 50% of the tropical lichen microbiota is unknown. It's not explored. So, if you see the diversity of lichens in India, according to the latest compilation by Sinha in 2021, there are 2,985 species of lichens in India, with six subspecies, 35 varieties, two pharma, totally 3,028 taxa are there, and 15% that is covers the 15% of the world lichens. It comes under 469 genera and 88 families, and about 19% of the Indian lichen flora is endemic to the country. And if you see the whole diversity, custos lichens are more in India, 2053 species, folios 729, and fruticose 229. And the lichens inhabiting the bark, the corticolas are more with 2,356 taxa, and also we have good number of saxicolas and terricolas lichens, and the folliculus lichens again. It's one of the important lichen community which are called as indicator species. They are also good in their diversity, 168 species, especially in Northeast India and Western Ghats. And in India, you can say these four regions: Western Himalaya, Northeast India, and Eastern Himalaya, Andaman Nicobar Islands, and the Western Ghats are the hotspots of lichen diversity. And Northeast India, especially, has a huge diversity of lichen, represented by 1,589 taxa. And if you see the state-wise, of course, state-wise lichens do not follow the state boundaries. It's actually the geographical or the geographical boundary it follows. But still, for your sake, so this is the lichen diversity in different states. Uttarakhand has the maximum diversity. That is because many people are consistently explore the state. So we are being close to the Western Himalayas or the Uttarakhand, we are repeatedly have gone to this area and explored most of the part of this state. That is why we have more number of lichens. It is followed by Tamil Nadu and other states. You can see, if you see the Northeast India, so we have more number of lichens in Sikkim. 636 species are reported so far, and it is followed by Arunachal Pradesh. And of course, all these areas, all these states in the eastern India are rich in lichens. Only thing is that exploration has not taken place. Especially Assam in 2020, there was a book published on the lichens of Assam where they recorded 300 species or so, but latest compilation of the lichen diversity in Assam, now we know 600 species are there. Of course, I have mentioned only 461 here. It's a little outdated data, but I mean to say that there are more number of lichens are there in the state than expected. So Manipur, you can see there are 441 lichens are so far reported from this area. While Eastern Himalaya has, or the Eastern India has more number of lichens, that is because we can see at least two biodiversity hotspots, that Himalaya and Indo-Burma are represented here in the Northeast India. And it has, that is why it has the elements of both these biodiversity hotspot. That is why it is richer in lichen. And for that matter, any biodiversity of any other organism. So coming to the Manipur state, we keep on exploring the less explored area, or the underexplored areas, or unexplored areas for the lichen study. So Manipur, although it is being explored from 1880s, but still there are many localities which are unexplored. So we got an opportunity to explore Manipur under 2-3 project, in fact. So that is why, and also there are few workers individually working there. So that is why we could compile and study the data of this state. So you all know Manipur is located in Northeast India, part of northeastern part of India. Um, it is almost at the junction of two world's biodiversity hotspot, that is Indo-Myanmar or Indo-Burma or Himalaya, and it has 16 states, 16 districts. Elevation ranges from 40 meters to 2,994. That's almost 3,000 meters, and highest peak is Mount Tempu peak in this area. And because of the altitudinal gradients, vegetation and health and all, it has the different climatic features which is suitable for the growth of lichens. And if you see the vegetation, there are 6 major types of forests are there, and 10 subtypes: tropical wet to evergreen, tropical moist deciduous, tropical dry deciduous, mountain wet temperate forest, subtropical pine, subalpine. These are the 6 major forest types in this in the Manipur. And if you see that 77%, 2% of the 77.2% of the state is covered by the forest and trees. And of course, there are 22.8% this has the greenery and also water bodies. And 67.63% of the forest in the Manipur states are have the legal status. They are protected. There and then of course, I mean, it's unclassified. 8.2 is the protected areas. So, but in total, the forest in Manipur are well protected, you can say. And if you see the flora, there are 3,000 flowering plants, 41 primitive flowering plants are there, 75 endemic plants. There are many plant diversity is huge here. And even orchids, you see 2,049 species are there. And coming to the cryptogams, or the lower plants, or the non-flowering plants, the inventory is not very good. Only 300 species of pteridophytes have been well documented here. Although there is a good diversity of algae and all, so documentation is not that good. And coming to the lichen study in Manipur, as I told you earlier, from 1880s, the lichen exploration started. G. Watt, or the Sir George Watt, is the first person to collect the lichens from the Manipur state, and his collections were identified Muller agrovensis, who reported 101 species and who described 29 new taxa from that collection. Later on, in the monumental work of Singh and Sinha in 2010, of course, there are after GWAT, there are many other collections were there. There are cursory collection. The lichens of those collections are included in the monographic studies. There was no checklist published, and all such lichens were compiled by Singh and Sinha in 2010. Then totally there were 2,292 species were there. And then one of our collaborator, Devi Pinocchio, Devi Shiremai, she reported some lichens. 39 species were reported as new to Manipur. And Singh and Singh in 2015, they reported 20, it's 11 species of Graphidaceous taxa were reported as new to Manipur. And in our own study in 2020, I reported 55 species of lichens as new to the state. And of course, this collection, I'll tell you in the next slide, although it has some new to India, so we did not report at that time because it required a detailed study. Now it is ready. Five new to India are there. So in the latest compilation, Sinha 2021, he mentioned the occurrence of 453 species of lichens from Manipur. But again, we checked at this list carefully, and we know that from this list we have um, 448 species of lichens with 8 species as new additions. So this is one case study I would like to present for the Manipur. So this is the study of lichens from the FEEDS campus. FEEDS is Foundation for Environmental and Economic Development Service. It's an NGO located in the Senapati district of Manipur, and also SB Garden, Selvian Botanical Garden. They are 10 kilometers apart. So we got an opportunity to visit this campus. And we could collect some lichens and all. And this feeds campus has the mostly the thinner vegetation, much of light penetrating and cultivated ornamental plants are more here, whereas the Selvian Botanical Garden has the natural forest and semi evergreen forest kind of thing, and good number of lichens were there here. And we collected a total of 250 specimens from these both the places, which study resulted in 105 species under 48 genera and 24 families. And SBG recorded more number of lichens represented by 80 species, whereas feeds represented only 47 species. And and there were 22 species were common to the both area. And in both the areas, crustose species were more dominating than the foliose and fruticose lichens, and the families like Graphidaceae, Pyranulaceae, Fusiaceae, and Formulaceae are dominant in this area. And if you take the different genera, Pyranula, Graphis, Heteroderma or more. And uh, and from this study, as I told you earlier, 55 species were new to the Manipur state, and now we have 5 species as new to the country, and there are 1 or 2 interesting specimens are there. There may be new species, but it requires much more studies, so we could not publish them. We are not ready with that result. And if you see the lichen community in the both the area, it's a kind of study clearly indicates the kind of lichen diversity in the 2 different areas. SBG being uh, a natural forest with a closed canopy, than the feeds, it has more number of lichens, as I told you, and it has less crustose. But the important point here to see, the cyanolichens are more here. Cyanolichens are the one which have cyanobacteria as a photobind. They require much moist condition for their growth, and that's how SBG indicates that it has the more conducive condition for the growth of the lichens. Whereas if you see the parmeliad lichens, which are light loving, and the Pyrenocarpus lichens, they are also light loving. They are more in the feeds campus because it has the exposed areas are more. So these are the 5 species which are new to India. We are manifesto is ready for the publication. Arthothelium confertum, Herpethelum bayadum, Malmedia papilosa, Megaleria leptolechia, then Cartosalia erythrella. So these are some of the common lichens in the feeds and SBG garden. Especially the second one, you can see the B, which has the red apothecia. The this lichen is growing abundantly in this SBG garden. So during the wet season, it just appears red as a red spot. So it is called hematoma. So hematoma accolans. So these are most common species in the SBG garden. Similarly, the people who are go to Manipur, they visit this Kebulamjo National Park or Loktak Lake, where you can see the circular man-made structures are there on the water body lake here, Loktak Lake, and this is for fishing and other purpose it is made. And also the this national park is a floating national park, it has a decomposed plant material. So so it is located in the Bilaspur district of Manipur, and it is established in 1966 for the conservation of this deer. It is called Sange deer. It's a very special deer in this floating national park. So we collected around 100 specimens from the Loktak Lake or the Kabilanjam National Park, so which resulted in 31 species of lichens. Again, the study resulted in the these 7 species as new records for the state, and this is this result we have to publish, and these are those 7 new records, and totally now we have 453 species of lichens from the Manipur. I'm very sorry for the little confusion I'm creating. Now we have 453 species of lichens from the Manipur state, which is which comes under 128 genera, 44 family, 15 order, and all. So Parmeliaceae lichens are more in the state. It is followed by Graphidaceae and Caliceales. And again, among the different genera, Pyronulaceae, Graphes, Parmatrima, Heterodermia, Lechinora, Leptogem are the more common and the dominant lichen groups in the state. So if you see the growth form, the crustose lichens are more, followed by foliage and fruticose lichens, and the corticolous lichens inhabiting the bark are more. It's followed by the saxicolous lichens, and you can also see that follicolous lichens are also in a good representation in the whole state. To conclude, frequent report of new reports from the lichens, new records of lichens from Manipur indicates the incomplete or the insufficient exploration of the state. If the trend goes like this, if we keep on recovering the new species, recording the new species from the state, the state may have at least 700 species as a whole from the state, and further exploration is required in the state with the focus towards the interior and inaccessible areas in the state, because the Manipur is one of the tough area for the exploration because of the insurgency or the local terrorist organizations there. So present data will be helpful for the preparation of the monographs, floras, and all of this the state, and also biomonitoring studies in the state. So with this, thank you for your patience hearing. If there is any queries, I'm willing to answer that. Thank you.
Thank you, Dr. Sanjay. Thank you very much for your nice presentation, very illustrative. Thank you very much.
Thank you, sir. Thank you.
It's really remarkable to see such a wide diversity. One small query.
Yes, sir.
Is there any indicator species from Manipur region?
Yes, we there are many. We didn't actually pick them, list them, but certainly these cyanobacteria containing lichens, they are indicator species. They indicates the health of the vegetations there, and since they require much humidity there, one thing is that they indicate that the forest area is much humid. And also these folliculous lichens, the lichens which grow on the leaves, they're also more in the area. They shows that some of the forest regions in the Manipur area are the undisturbed or the less disturbed because they grow in the undisturbed areas.
Yeah, thank you very much. And I request the participants who are interested to have more idea about the lichens to contact Dr. Sanjeev. He's a world authority now on the lichens, wonderful worker and a great inspiration which he gives. Periodically, he conducts workshops in his institute. So thank you, sir. Thank you very much.
Thank you, sir. Thank you for the opportunity.
On behalf of the
MSI
organizing committee, I thank you very much. And the next speaker is Dr. Yogesh Joshi. Is he here?
Yes, sir. He's offline.
Okay.
He's here, sir.
Yeah.
Okay. So,
29.
He is the MSI ex-executive council member. He is the executive council member and from the Department of Botany, Central University, Rajasthan. And he will also be speaking on the lichens. Dr. Joshi, please.
Dr. Joshi, 20 minutes, please. Kindly
Yes.
restrict to 20 minutes, please.
Yeah, sure, sir. Whether I am audible, sir?
Yes.
Yes.
Please share your slides.
Yeah, wait a moment, sir. Please. Uncle?
Ready, namaskar.
इससे लगा दूँ तो ये है.
Good morning to everyone.
बट बड़ा है. It will generate.
this is the first Lichenicolous fungi reported from the world. This is Biotropsis acinerum. It is also located in India. So gall-like structures are formed on these lichen thalluses, and this is a common cystic. In this case, a fungus grows on the lichen thallus, and the same alga provides food to this fungus as well as to the lichen, and they grow in a three-bind symbiosis. This is Dactylospora. This is my first Lichenicolous fungi when I was in South Korea. I identified it, and then from there I got interest in this group of fungi. This is mutualis. Here a fungus grows over, this is another lichen, this is another lichen. Fungus grows over another lichen. It kills the primary microbiome and makes new microbiome. So this is a four-biont mutualist association, four-biont. So these are some new species, new genus which I have described. This is Ajaysinga dendrostite, and this is Jejula from Jeju Island, South Korea. This is Polycocum. Now you can see this is Pertussaria, and in this is also Pertussaria. Now here you can see this is a single perithecia. Here the perithecia are growing in galls, and here this is a pycnidia. So a same host is having three different types of fungus on itself. So again, this is a Pertussaria. Here it is a lily-like structure. This is Sarsidospora. These all are new species that's being published. So you can see, have a look here. So these are some new records. There are near 200, 300 new records I have just provided. Now, what's the problem in identifying these fungi? Because lichenologists, they don't know much more about the mycological terms. That's a big problem. And mycologists rarely collect lichens, and they don't know about the fruiting bodies of that. So this is the problem, that they do not work together. That's a big problem. Another thing is that in this group of members, Esco, Basidio, Silo, and Hypo, and a person can be expert in any one field, either Esco, Basidio, or Silo or Hypo. But here you can see everything is coming in a single place. So I cannot be an expert in every field. And it's just like finding a needle in a haystack. So if you search for 1,000 or 10,000 samples, you will find one being infected. So it's that much difficult. So for example, this is Thamolia vermicularis collected by my student when I was in Uttarakhand. It's looking like normal. Everything is normal. So it's a single segment. After careful observation, I found a single being infected. Out of this 150 or 200, it's only one is being infected. Now, if you see it, this is this. It's being infected by Stigmedium. So similarly, there are endophytes which have been isolated by myself from this lichens, and Mary Koska was the first person who termed endolichenic fungi, and you can see here. So these are the endolichenic fungi. When I was there with my students, I have isolated it from, and this is the technique which we have modified it from Suryanarayan et al. As per the conditions. So this is the protocol how we used to do it, and everyone know that how to culture the endophytes. So this is it. Why it's being important is that if you see here, only 59 lichen species out of 50,000 have been screened for their endolichenic fungi, and of the 351 secondary metabolites, if you see here, 196 are novel compounds. That's the important thing about this, and they produce sometimes the similar compounds as that's produced by lichens. So these are some structures you can see here, and this is the book which we have published from Springer on endolichenic fungi, and these are the images of that. So what has happened is that first report of lichens was by Linnaeus, and regarding Lichenicolous fungi, again it was a European person, Morio, who reported Teleminium. Now it is Opigrapha foriae. And as far as the Indian lichens are considered, Qureshi was the first person who reported lichens, and then Avasti and Singh reported Sphincterina as a Lichenicolous fungi. But the turning point in this come in the year 1948, when we talked about lichens, when Dr. Avasti started his school of lichens. And for regarding Lichenicolous fungi, it was 2013 when Zurbenko for the first time visited Jammu and Kashmir and collected lichens without knowing the authorities of India. We have no records, and he has published near about 25 new records from that place. And Now, if you see the percentage of finding of new species, here it is 12% and here it is 10%. So, as you know that lichens are very slow growing and they are enormous source of secondary metabolites. So, if we use them, then diversity will be lost. So, best thing is that you can culture endolichenic fungi and you can get the same set of results, even sometimes novel compounds. And these black fungi, rock inhabiting fungi, lichenicolous fungi, microcondylial fungi, hypomycetes, they are the most stress resistant eukaryotic organisms and they can be treated as model organisms for astrobiology. And you can see this link and you can here have a look on this. They have across the world, what they have done, they have utilized Aspergillia, Buellia, Saturnaria, Rhizocarpon, Xanthoria, Russacia elegans as a space organism to study the environment of space. And of this, this, and this, it also occurs in India. But we didn't have sent it to Mars or some other space. So you can see I have taken just an example of Xanthoria elegans. Now it is Russacia elegans. The same species, it's the same one, different angles. Now you can see the black dots, black dots, black dots. This is black, here black patches, and this black. Now a single lichen with different black dots for Oxford group from 2022 by Duking that stable supporting association of fungus or fungal-like organisms. That's why we have written fungal-like organisms, the primary microbiome and the morphology undifferentiated unicellular to filamentous algal and or a cyanobacterium, the primary photobiont along with obligatory associated elements of the fungal and bacterial microbiome contained therein. So if a person is working on taxonomy of lichens, then he has to use the term lichenized fungi or lichen forming fungi. And if he is working on ecology or some bioprospection studies, then he or she can use the term lichen. Then it's not an issue. But if you are working on taxonomy, then you have to use the word lichenized fungi. So I would like to thank Dr. Upreti because he was my guide. Dr. Naika, who during initial studies told me that how to do the revision work. Satish was my PhD guide, and Lakhan Bhatt was my examiner. So he congratulated me that you are now doctorate. So afterwards, I'm doing this. Rajesh Bajpayee, and this is my student who helped me a lot. And these are the funding agencies. And once again, thanks to Mycological Society of India for providing me the chance. And so now this is time. If we shake hands, we can get enough. Thank you.
Thank you, Dr. Joshi. It's a wonderful lecture on, and I am also delighted to hear about the endolichens. It's a fascinating area.
Thank you,
sure about it. Yeah, wonderful lecture. I request all the participants of and the members of the Mycological Society to contact him for these lectures. Yes, probably one. Yes, Dr. Afzal Ahmed. You have any questions?
Yes. Thank you. Sir, in NBRI, Upreti sir and their team, they have tried a lot to culture the lichens, but the drawback is that they are two partners, algae and fungi. So we cannot culture both. So the best thing is that we culture the microbiont of that. It will give the same result as that produced by like. Sir, maybe same and sometimes different also. Definitely. Yes.
Not sure. Same compound you are isolated from the natural common lichen and then microbiome, whether you will get the same compound or not.
Sir.
I think, excuse me, yes. We will continue this discussion a little later, I mean, when during the off time. And since we are running behind the schedule, I think we'll go for the next lecture if you agree. So I thank Dr. Joshi for this nice talk. Thank you very much, sir.
Next, it's ready.
Yeah, we have.
It's talking.
Next,
Ready?
Shall we go for the?
Yeah, Professor Reddy is there, sir,
Yes.
online.
We have Professor Sudhakar Reddy with us, who is the treasurer of Mycological Society of India. And he is also a professor in the Department of Biotechnology, Thapar Institute in Patiala, Punjab. He's an expert on endophytes, although he did his initial work on mushrooms under late Professor Natarajan, a respected teacher from University of Madras. And he's an authority on the secondary metabolites of these endophytes. I request to give his talk.
Thank you, sir. Good morning to everyone.
Professor Reddy, 20 minutes if you
I know, sir. But can you allow me to share my slides, please?
Yes. Dr. Madhivanan.
Madhi, just tell the organizers to allow me.
Professor Apsar, tell them to share, accept the slides.
Yeah, it's okay. It's taking time. Okay. Are you able to view my slides, sir?
Yes, it is coming, sir.
Okay, so very good morning to one and all. So thank you very much for giving me the opportunity to present some of the work. As Professor Bhatt said, sir, I'm still working on mycorrhizal fungi, but this is a work which I did it with someone, so it's interesting. So I would like to present the results. Okay, so the title of my topic is on later endophytic fungi, which is a potential source for the differently enzymes or industrially important enzymes. Okay, so when we talk about the enzymes, okay, especially the enzymes which are produced by microbes are more preferred than the enzymes which are produced either by animals or plants. And these enzymes have enormous potential in various industries, which includes pharmaceutical, food, feed, beverages, detergent, leather processing, and paper and pulp industry. And as I said, microbial enzymes have gained a lot of interest because of their widespread use in various industries and also in the health sector due to their stability and easy to produce. And also you can optimize the conditions to produce the maximum amount of enzymes, okay, when compared with the plants or animals. And production of industrial enzymes by bacteria has been explored since long, and bacteria such as bacillus, okay, so genera has been explored to a very great extent to produce the enzymes. Okay, so recently the enzymes produced by filamentous fungi also gained more interest because of its advantages over bacterial enzymes, especially when you compare the bacterial enzymes versus the fungal enzymes. The fungal enzymes have the capability to produce high production with a low cost and the rapid development, and also the enzymes can easily be modified and are also recovered from various substrates. Apart from these, the fungal enzymes are secreted extracellularly, so it's very easy to extract or you can isolate. and it also grow on different agriculture or many complex substrates like constip liquor and other things which are very cheap. And you can do both solid and liquid fermentations to produce these enzymes. Okay, so these are some of the advantages of fungal enzymes over bacterial enzymes. Okay, so when coming to the endophytic fungi, so mostly endophytic fungi, as many lectures might have already happened, and everybody is aware that endophytic fungi are more important fungi which produces different or various secondary metabolites which have a very importance in the medicine and also health sector. But the one which I am going to present is in a different aspect. As everybody knows that they live inside the plant tissues without causing any sign of infection during either all or part of its life cycle. For the last 2 decades, it has been explored for various biochemical compounds for various therapeutic purposes, and various compounds like terpenoids, steroids, xanthones, quinones, phenols. Okay, so benzopyrines and isocoumarins are all have been isolated and also purified and used in different ways. And these are the compounds which are produced by endophytic fungi by using different biosynthetic pathways. Apart from these secondary metabolites, okay, these fungi are also known to produce some of the enzymes like lipase, amylases, and proteases as a part of their mechanism to overcome the defense of the host, especially when the interaction takes place between the host and fungi, okay, to obtain nutrients from their development. As we know that these fungi do not cause any sort of sign of infection during their development in the plant system. And so some of the cases like cellulose and lignin production, they depict a strategic benefit to decompose the tissues and also make these fungi as saprophytes, especially when the leaves fall or during the case of senescence. So if you talk about the diversity of endophytes which comes from different regions or areas, if you can see that endophytic fungi is everywhere in tropical, mangroves, high altitudes, deserts, and temperate and Antarctic regions also. Because of these various the habituates and also the adaptability to live in different conditions, most of these fungi, okay, when you screen for a different enzyme, so they are the the candidates which will produce different types of enzymes with a varied characteristic features. Like many of the enzymes may require different characters depending upon their use, like high pH stability, thermostability, flexibility, and all. So all these things are basically acquired because of their habits at different places. So these enzymes can be used in various sectors like food sector, pharmaceutical sector, agriculture, and also biofuels and many other places. And also everybody will know that nowadays co-cultivation approach is a very important approach to produce either secondary metabolites or any other parameter. So you can also explore these fungi for these sort of an applications. So if you talk about fungal enzymes, or especially endophytic fungal enzymes in agriculture sector, so when you do that, the enzymes like gelanases, glucosidases, chitinases, and cellulases have already been reported, though not commercialized yet, but they are very important to play a role, especially in the degradation of biomass. So then biocontrol are, and also these fungi have been explored now recently as a plant growth promoter. So this is also another important concept of these endophytic fungi. So one of the questions which arises now, but why do they produce like cellulases and other enzymes which are basically so these enzymes they degrade the cellulose and other things, and if these organisms are living as a symbiotic association, then how do they become as saprophytes? So endophytic fungi really they are saprophytes or they are symbiotes. So it has been proposed a sort of a mechanism in this case that so most of the endophytic fungi they maintain the symbiotic relations when they are associated with the plant or with the live tissue. As soon as the leaves and the other things will fall on due to senescence and all. So many of the fungi which lives on these tissues or the things, they disappear, and some of them remain active and they turn to be a saprophyte. And these saprophytic fungi, because they are especially in the litter and other debris, so they turn into a saprophyte and they start degrading by producing various enzymes which are essential for the degradation of organic matter into a simple sugars, which could be used as a source of nutrients for the fungi. Okay, so these these enzymes which are produced by these fungi have been explored again for various purposes because of its stability, okay, and also better yield in these industries. So this is the base. So as we could see that some of the endophytic fungi, okay, when they are not
I think his connection, he will come back. Yes.
the spores were tested for various temperatures. If you look into this graph on your right side, okay, so there is a different types of the endophytic fungi which we have isolated from this leaf litter. Okay, so which are able to tolerate, okay, like maybe 6 hours, 5 hours, 7 hours, 2 hours, depending upon the type of a genus or a species. See that some of the fungi were able to tolerate up to 115 degrees when you incubate them. The spores were incubated in the oven, and then we are able to regenerate them. So this indicates that these are basically are able to tolerate to high temperatures, and then we have linked it because whenever there is a forest fires which takes place, so most of these fungi, okay, so they burn along with the litter. Okay, the spores which remain there, they still survive. Okay, so like like 115 degrees for 2 hours. You see, this is the fungi, Botulinia, able to produce, okay, able to survive even 2 hours. Some of them are able to survive 5 degrees for 6 hours, 8 hours, like that. So we can make a link between this. So that's why we call these fungi as Agni fungi, because they have high resistant to the heat and able to survive in a very extreme heat conditions, like up to 110 to 115 degrees centigrade. So the hypothesis came from this, that whether these litter endophytic fungi, which have the ability to tolerate to that extreme environments, when we grow them, are they able to really produce the enzymes which are thermostable and also the other processes. Of course, we have completely characterized these fungi, and we have been identified by using a phylogenetic analysis, which belongs to various groups, okay, like Gelanaceae and many other phyla which are there into that. And so these are all some of the endophytic fungi which we have screened for various enzymes. Okay, so Botany, also Cupularia. Okay, so like that, if you see Puma and the Crystallopsis microscope. Is a sort of a echo is coming? Is it because of some problem? Okay, so then if you look into that, so we have tried this for various enzymes under by using a plate assay, like cellulases, licases, amylases, lipases, pectinases, proteases, asparginases, and tyrosinase. And this table shows that some of these enzymes were able to produce like cellulases, and some of them are able to produce amylases, lipases, and also on. So this indicates the maximum and moderate and low activity. And so these are all the just to give an idea that how like cellulase and lacase and amylases or lipases, how they were screened under in vitro conditions by using a plate assay to know that they are the candidates which can produce the enzymes like the proteases. And some of these isolates of 9, they were unable to produce either pectinase or thyrogenase activity in these particular cases. And of course, most of the fungi are able to produce aspergillus activity. Okay, so this, as I said, that the main aim of our study was that these agni fungi, which have the ability to tolerate extreme temperatures, are they able to produce the enzymes which are also thermostable so that it could be exploited for industrial purposes. This was the hypothesis which we put forward, for which we took some of the fungi which are tolerated at high temperatures, and we studied both cellulase and lipase enzymes, and I'm going to present these results. Cellulase have, have a massive industrial requirements and is produced by many industries worldwide by solid fermentation and also submerged fermentation. And especially you can use lignocellulosic biomass to produce this, so that you can use the waste or the organic waste to convert them into cellulose. Though much work has been done on many other fungi for the thermostable and pH tolerant cellulases. Okay, endophytic fungi have not been explored, as the more work has been concentrated onto the medicinally important or secondary metabolites. So we explored this for the production of enzymes. Okay, so then as you see that most of the enzymes which are used in the industries, they should be capable of resisting to various extreme conditions like extreme pH, extreme temperatures, osmolarity, pressure, and all. So that's why, as the endophytic fungi lives in extreme harsh environments, so you can correlate and see that if enzymes which you isolate from such environments will have the ability to resist to these extreme environments, so that you can use in that context. We have studied these enzymes. So then, if you look into that, so out of these 9 fungi, the Botanylia, the Pondiensis was able to tolerate or produce a high cellulose activity, followed by the Phoma species. So I'm presenting the results with one of the species here. And this is how, so we collected the fungi. This is a graphical abstract to explain the process, what we have done it. So this is a forest prone area where these fungi were collected, and then, okay, so we have grown them and we have estimated for cellulase, and these enzymes were able to tolerate extreme temperature and pH environments. And if you see that, okay, the activity, so that when we incubated them at different time intervals, the maximum cellulase activity was obtained at 9th day. And also when we use the different carbon and nitrogen sources, and again you see that some of these were able to induce the growth as well as the production of the enzymes. Like that, you have both organic and inorganic nitrogen sources also able to induce the enzyme activity. And some of the like a natural carbon sources are organic waste like wheat straw, rice straw, banana leaves, sugarcane bagasse, okay, so then eucalyptus leaves. So we have all tested, and by growing the solid state fermentation, and then we estimated the cellulose activity in the form of CMCase activity, and see that eucalyptus has promoted the maximum activity, okay, so followed by rice bran and also the wheat straw. So then the most important thing in this is that the pH and temperature. So you see that these when we grow these fungi under buffered conditions, and also we tested the enzyme activity by incubating the enzyme at a different pH level. So this enzyme, though it's stable at 6, but the activity is not lost even at a pH of 10. And this is the most important component. You see that as the enzyme, when it is incubated at 2 hours time at 100 degrees at different time intervals, as you increase the temperature, the enzyme activity also increased. And even in 100 degrees centigrade, the activity is very, very high in this case. So like that, then we studied the thermal stability. And if we incubated the enzyme at a 60, 80, and 100 degrees centigrade, and you see that this enzyme is more stable at 60, and okay, so then followed by 80 and 100, but till 2 hours, okay, so the enzyme is almost stable within this temperature, so which clearly indicates that this fungi really help to produce these enzymes which are thermostable and pH tolerant in these environments. And this is a demographic analysis which we have carried out to study the activity by incubating these at these temperatures, and we're able to assess the activity by using demographic analysis. And the next enzymes which we studied were lipases. As we know, lipases occur widely in nature and are primarily produced by animals, plants, and microbes. And microbial lipases again have a many importance compared to the other, especially in various industries due to their flexibility in temperature, pH, and able to tolerate to the different organic solvents. And again, both fungi and bacteria produce, and the fungi will have more advantages over because of its extracellular secretion of this. Again, the same fungi when we tested, the Leptospirulina trifoli has showed maximum activity for the lipase. Of course, all of them are also produced, but these have more activity. So further studies were carried out by using these fungus. Okay, so this is the twin 20 plate assay, which shows the precipitation around the fungal colony. Okay, due to the lipase activity, you see that a lot of crystals which have been formed due to the presence of that. Then we have also studied the by growing the culture at different time intervals, and again you see that maximum activity was obtained at 6 days. So further studies were characterized, or the fungus was grown up to 6 days, and the activities were performed. And of course, there is no change in the pH while the organism is grown, so they remain constant, whatever the pH which we have adjusted at the initial stage. And if you look into the specific activity, so we used different oils, like this is a basal medium. Then we have used mustard because it's a lipase, so we use different the oils like mustard oil, soybean oil, coconut oil, and also sunflower oil. So the soybean oil and the sunflower oil have significantly induced the enzyme activity compared to the other things. And again, nitrogen sources, if you look into that, soya meal has more impact on the enzyme activity compared to the other nitrogen sources which we used in this study. Then, if you talk about a pH and temperature, as you see that this enzyme, which is produced by Leptospirulina trifoli, okay, so it is much stable, and also the activity is very significantly much higher, even pH at 11 compared to the lower pH. So it means that the optimum pH for this is 8 to 12 or 8 to 12 if you look into that, but the maximum activity was obtained at 11 pH. Again, temperature, if you see that as you increase the temperature, the enzyme activity significantly increased. So we did not test above 100 in this case, but you see that till 100, the enzyme activity is significantly higher in this case. Then we also tested the as a part of the enzyme characterization by using a different divalent cations like calcium, manganese, copper, zinc, and EDTA to see whether these have any influence on the enzyme activity. And if you see that manganese significantly increased the enzyme activity compared to the other divalent cations in these particular cases. So these were the two enzymes which we have tried, and of course we are continuing to do this further for other enzyme activities. To conclude my talk, so most of the litter endophytic fungi like Bacteria apandiosis, which has been isolated from fine-prone forest area, is able to produce cellulase with a high thermostability and also pH tolerance. And this cellulose, which is produced by these fungus, have maintained more than 50% of its activity almost for 2 hours at 100 degrees centigrade. And the other litter fungus or litter endophytic fungi, Leptospirulina trifoli, has produced a lipase which have a high tolerance to both temperature and varied these activities for a pH. And this fungus also again maintained 50% of its initial activity for 1 hour above 50 degrees centigrade. and it has been increased in presence of manganese and calcium ions. So these results basically suggest that litter endophytic fungi, which we isolated from 5-cone forest areas, have the potential source to produce the industrially important enzymes, especially in their thermostability and also the alkali tolerant enzymes. This is what I would like to convey by my lecture. And these are all the team. So Dr. T. Suryanarayana and his team. So who have initially isolated, and we have molecularly characterized, and the further work has been done at our institute. Dr. M. Vasundhara, then these are the students like Rajni Sadhav, Kirti, and Rajamani. So these were the students who are involved in this. So I again thank you very much for your patience.
Thank you.
Okay, thank you, sir.
Thank you very much. Wonderful talk you gave on this Agni fungi.
Yes, sir.
Fire-prone areas. I'm just curious to know whether I understand there's a lot of burning of the fodder activities taking place in Punjab. Have you
Yes,
isolated any fungi from that region?
No, that we have to try. That's what I just this gave an idea for me to do that. So,
Okay.
so we will do that particular thing, sir, in that particular case.
Wonderful. I say,
But
in
this
any
is
case, this is a
yeah.
remarkable work that you have presented, and it will give a lot of hope for the young people to work on these areas. Thank you very much, sir. Thank you.
Thank you, sir. Hope I maintained my time.
You have really maintained the time. Thank you very much.
Thank you, sir.
I think we have two oral presentation as per the by Professor Murugesan and Professor Kalaishwalam.
Yes, sir.
Are they here, both of them?
I think both of them are there, sir. In the hall.
Okay. And we have 10 minutes each.
But yes, sir. Sir, once again, sir. The second lecture by Dr. Amma, she is not here, so therefore feasible now. Now we can allow Professor Murugesan to speak for 30 minutes. Could you hear, sir?
Sir, will you repeat again what you said?
Sir, we have Professor Murugesan
Okay.
here. You will be talking through offline. And the second speaker, Shankaramal, she is not here. So therefore, that lecture may not possible. So probably we can permit Professor Murugesan to speak for 10 minutes, sir.
Okay.
That's
Okay.
Yes.
Thank you.
So we
Thank you, sir.
invite Professor Murugesan to deliver the first talk for about 10 minutes time. Yes. Professor Murugesan, please.
Yes, sir. It's opening, sir. It's opening.
Yeah. He is from the Department of Environmental Sciences, Periyar University, Salem.
Sir, I am the alumni of that CAS Botany, sir.
Yes.
Yes. Wood inhabiting fungi and their biocatalysts for sustainable environmental application and ecological restoration. There's a topic on which he will be speaking. Professor Murugesan, please.
Yeah, it is opening, sir. First of all, like, express my sincere thanks to all the MSI office directors for giving this opportunity. Respected chairperson, the directors, and the MSI president. Good morning. Of course, good morning to everyone. So, open. Okay. My PPT is opening, sir. Before that, I will introduce my topic. So I am the alumni of the CA Center for Advanced Studies in Botany, University of Madras. So I take this opportunity to thank all our previous directors and Sir, the slide is visible, sir. Is my slide is visible, sir?
No, not yet. Yes. I think it is just starting. Yes.
Okay.
Yeah, we
So
can
as
see your
all
slide.
the CAS alumni know that there was a big tamarind tree in front of the CAS Center for Advanced Studies in Botany. That tree was fell down due to the this candidate Ganoderma lucidum because they infected that tree and they fell down. Then my supervisor started that research on that Ganoderma and the aspect, and he got many projects from UGC, ICFR, and the DST and various aspects. And I joined. Initially, the ICFR project to explore the Ganoderma diversity in the Western Ghats, and also we have collected so many other wood rotting fungus. When I reported, then we faced the difficulties in the mainly the identification of the these wood rotting fungus, particularly the Ganoderma species, which is highly complex. Then I worked with the pathological aspect also. And after that, then I moved to the applied aspect with the enzymatic of this Ganoderma species. So the Ganoderma is very difficult to cultivate and culture in the laboratory in our condition, but our laboratory successfully, our professor culture in our laboratory we cultivated with the optimization of the process. Next one. Next one, yeah. So this is about the prevalence of the Ganoderma species. It more attacks more than 300 species, and it's widespread and well all over the world, and they produce a very devastating effect in many plantations. Next one. So we know that there are so many natural polymers. The cellulose or the lignin are the most abundant polymers. They are the main source for the wood degrading fungus. They convert. They replace these polymers for their growth, and they also convert into the chitin as a main body of the fungal body. So we use these natural polymers nowadays. We use for many applications, including the energy production, and also for the energy saving materials using by converting these polymers. Next one. So this is the lignin. So this complex lignin is highly complex lignin and complex lignins. So all these lignins are made up of these three basic common lignin monomers. So this lignin highly complex lignin contains more than 13 to 15 different linkages, very difficult to degrade. But this wood inhabiting fungi, they are able to degrade this very highly complex lignin due to their effective enzyme system called as the lignolytic enzymes, which contains mainly the three enzymes and many accessory enzymes. Next one, yeah. So this highly complex lignin is degraded by the various kinds of wood degrading fungus. They attack both the dead wood as well as the live wood. So live trees. Next one. So, the wood degrading fungus, different classes about brown rot and white rot depends on their degradation pattern. So brown rot fungi they mainly replace cellulose and hemicellulose, whereas the white rot fungi they degrade the lignin, and many even within the white rot fungi they have different degradation patterns. Some of the white rot fungi selectively degrade the lignin than the cellulose and the hemicellulose. So after the degradation, you can see like this wood is this is degraded by the brown rot fungi, this is the degraded by the white rot fungi. So selectively remove the lignin, so they leaves the residues of the cellulose. So this white rot fungi that the enzymatic system very applicable in the many industries, particularly in the pulp and paper industries and also textile and many other industries. Yes. So these are the major main catalysts: lignin peroxidase and manganese peroxidase and lacase. So considering these lignin peroxidase and manganese peroxidase, they are the more potential and they degrade the non-phenolic common linkage, whereas the lignin lacase is the compared to this lacase is the very the redox potential, the oxidation potential is less compared to, but this this lacase is more advantage compared to the other things because very easily we can put it. So many of the fungus constitutively produced, and also for the application aspect very easy, and purification handling is very easy compared to the lignin per access. That's why their case is finding this having a very huge applications in the biotechnological industries and as well as in the environmental aspect. Next one. So these are the screening methods for from the wood rotting, because the white rot, the wood decaying fungi produce this lignolytic enzyme in different patterns and depends on the nutrition available conditions. Some of the fungi produce only the leaf and manganese peroxide. Some of the fungus produce only the latex specifically. Some are combination of all these enzymes. Depends on the nutrition. The manganese, the main enzyme. Another is the manganese peroxide, a main enzyme than the latex. So we can easily screen which kind of fungus produces which kind of enzyme. So we can easily screen out for the for the further applications. So we use the different kinds of dyes or some other colored substances which can actually, when we produce that substance are oxidized, then generate the color. So these are all the screening methods for the latex from the different fungi. We included the another also the Ganoderma and other fungi, and also we included the Pleurotus and many other articles. So here you can see this is the very simplest method for the screening, and we can easily find out the potential fungus for the enzyme production and other applications. So, on the laboratory conditions for the initial optimization process, we use the fast culture. Then for the mass productions, we utilize the solid state fermentation using the wheat bran as a material, and also we used many other materials, and I only the wheat bran. So, for using from the Ganoderma, we can just extract after the growth. We can extract the enzymes, the crude enzyme after the filtration. The crude enzyme we can directly apply to the field for environmental applications. So, and also we can produce through this solid state fermentation after the cultivation. We can collect the extract from this spent mushroom substrate, a huge enzyme. We can collect it, and we characterize this secretome enzymes using that ITRAC method, the mass spectrometry method, and we confirm that more than 63% of the enzymes, extracellular enzymes produced by this Ganoderma is the lignocellulosic enzyme, including the cellulose and lignin peroxidase and the hemicellulose, including the xylanase. So that we have this is a confirmation of the using the protein profile with the gel. We confirm the enzymes using the zymogrammic techniques. So the Ganoderma in the which produce the and this enzyme depends on the conditions and growth patterns and the nutrition requirement. When we supplement, we can induce when we add some aromatic monomer substances, we can induce the enzyme to produce more. So this is also confirmation of the degradation and dye degradation aspect, because we just to check whether the zymogram. Regarding environmental application, these are all the non-specific enzymes. The beauty of these enzymes is they are the non-specific. That means the latex is specific for the phenolic compounds, but due to its ability to degrade synthetic redox mediator compounds, redox mediator arms after the oxidation, that radicals can attack non-specifically many wide range of the aromatic pollutant compounds. So that's why this enzyme is finds a very effective application in the environmental aspect. So far, so many different pollutants have been reported for the transformation and the detoxification. So in our studies, we have focused with the many kinds of synthetic dyes and also the pharmaceutical compounds for the detoxification studies. And also many reported studies reported that they are very useful for synthesis of the many novel drugs for the cancer treating, also cancer treating compounds. And recently in technology, the latex enzyme and other degradation finds a very effective place for the synthesis of the nanoparticles as well as the for the nano bio treatment of the detoxification of the compounds. Next one. you can see here there are a variety of pollutants. These are all the pollutants which we use in our daily life. Many of them are the pharmaceutical compounds, and also this is most widely used the common triclosan compound. So this is included in the many of the pharmaceutical our personal care products. Wide spectrum antibiotic compound. But when we expose to our body, it creates a lot of uh, impact on our body because they directly interact with our hormonal system. So, and we focus to detoxify and remove of this kind of compounds using these enzymes in various forms. Yes. Oh, so here use the different kinds of rice. We know most used in the textile process, and so many different groups. Yeah, for all those with the lacase as well as the lacase redox material systems. So this is initial screening. Next one. So we took the redox data system for the proving the detoxification of the one of the important dye, malachite green. The dye malachite green is it is a fungitoxic. It is a dye also used in the textile as well as used in the as a fungitoxic compound in the many aquaculture to inhibit the fungal growth. But we utilize this compound to inhibit that live culture of the white fungus, including the Phanerogated cryptosporidium, very effective. Lignin degrader cannot grow with this dye when in the presence of the dye. But if we use that extracted enzymes, these dyes are detoxified. We have found out the mechanism using the GCMS chromatography. We found this is the initial control compound of the malachite green. So when we treated with the lacase and the redox mediated system, when these redox mediated systems are small molecules, this is synthetic compound. But at the same time, there are so many natural redox mediators. Natural redox mediators, these are all the lignin monomer compounds. They act as a redox mediator. So that is the beauty of that is a very important aspect of the this kind of enzyme. So they act as a redox mediator. They very effectively, and also the mechanism is different from the synthetic mediator. So we found that the sequential degradation of the malachite green and completely remove its toxicity. So this is the malachite green. So they sequentially remove the toxic group from that compound and then finally produce the non-toxic compound. And we tested the toxicity using the next one. This is a Phanerogated cryptosporidium we utilized it. So with the in presence of the malachite green, that fungus very effective lignin degrader fungus is unable to grow. But when we compared with many kinds of synthetic mediators and natural mediators, the toxicity is reduced very effectively. In case of the lacase mediators and lacase syringal ligand, which is a natural compound syringal ligand from the natural compound, it was very effective, and the mechanism is different from the synthetic mediator. So compared to the synthetic mediators, these are natural mediators are less. And also we tried this better fungi for the remediation of the dye contaminated soils, where we found that the fungi are effectively colonizing the substrate. We added the substrate with bran, and then they also able to grow with the dye contaminated soil. This is a sludge. Next one. This is a sludge after the treatment of the dye wastewater. The common effluent treatment plant, they just accumulate, they heap this sludge in the premises. So we also tried with to remediate these sludge. They colonize and the toxicity is reduced with the these enzymes secreted by the enzymes secreted by the fungus can polymerase and remove that toxic common we studied the in the sets. And also then we also try to utilize these enzymes for the reaction and application of recycling of is very important. Then we conjugated this enzyme with the difference, and we found that many times we can recycle that enzymes for the applications. Next one. So finally, so apart from this, our other environmental applications, we found that these lakees plays a very dual role, both in catabolic activities as well as in anabolic activities. Anabolic means the synthesis. So it due to that activity, so we decided that using that monomeric compound, we can develop many kinds of polymeric compounds with very wide range of the colors. We tried that, and this is formation from the monomeric lignin compounds. With a combination of monomeric compounds, we have blended it, and we found that generation of the many colors. These are all the natural colors. We applied these natural colors to the hair dye. Okay, next one. So dyeing of the hair. So this is the control without the latex treatment. Then after the latex treatment, we found the generation of the different colors. Then use this color as this primary compound to dye this hair. We found that it's very effective. And next one. So these are the different dyes. So this is the natural dye. So it's non-toxic, and also we tested with the different washing steps, and after the even shampoo washing, it's persistent. So we can apply this. So this work was patented, and based on this synthesis, many other work has been published to develop the many other compounds. So I didn't present here. So in conclusion, the wood decay fungi play a major role in xenobiotic degradation and also remediation of the many kinds of water pollutant, including the emerging contaminants, which I have been working recently now. And the lakees and redox mediators play an effective role and detoxification emerging pollutant, particularly the persistent personal care products, mainly the antibiotics. That is the biggest issues. Antibiotics and other medical compounds are the biggest issues in the wastewater system, because we use huge amount of the pharmaceuticals, or most of them, all of them are released through the wastewater system, and also they are very ineffective in the treatment process. Also, they are emerging as emerging pollutants in the sewage with the effluent, so we can easily remove using the system. So we do that, and also lake's function both anabolic and catabolic process has a huge applications for the synthesis of many novel kind of compounds, and also now we have been focusing on some synthesis of the nano fertilizer using this lake's based synthesis. So that's what are under progress. So in the next conference we will present. Thank you so much.
Thank you, Professor Murugesan. It's a very informative talk that you gave, and very delighted to hear your talk. Maybe one question we can allow.
Yes, sir, please. Yeah, here, sir.
Professor Murugesan, it's very interesting.
Yes, sir. Here is there is a person here, sir, participant asking questions, sir, and I will answer.
Okay, please, yes.
Yeah. So the magnetic nanoparticle is the core. So the surrounding the magnetic nanoparticles we coated with some other polysaccharides, some the chitin or some other thing. Okay, so then through that we conjugated this enzyme. So here conjugation we can make it some glutaraldehyde with with the polymers, the natural polymer coated with that magnetic particle is not directly conjugated. That magnetic particle is just to trap with one, sir. Surrounding that the magnetic particle we coated with the polymers, the chitin or other. Sorry. It's not very easy. You are going to put the magnetic particle. So, we have to think in that direction. What is the charge on the magnetic particle? What is the charge on the So it could take nanoparticle adding to compound. Sir, the chemistry of that. You have to see the charge on the nanoparticle. If the charge is positive charge, then you can see the negatively charged compound. And if you have the negative charge, you have to make the nanoparticle positive charge. Then you can make the conductivity. Yes, sir.
May I intervene? I think we have.
Yes, sir.
Interesting.
Yes, sir. Yes,
this lecture is definitely interesting. So I suggest the participants to discuss with the Professor Murugesan during tea time.
Okay, sir.
I think that's truly is an interesting talk, sir. Sir, I have a message here for you by Professor Shashireka. She says she desires to have your email address. So please furnish.
Yeah, I will share it, sir. I will share, sir. And it is also in the.
Yes.
And I will share, sir.
That will be because this has generated a lot of interest in your talk. And that's an interesting topic.
Thank you so much, sir.
So I thank you, sir, for this nice presentation. Thank you
Yes,
very much.
Thank you.
And we have Professor Kalai Shelvan there.
Yes, sir.
As I mentioned, this presentation is not there, sir, because Professor Kalai student, she is not attending now. So therefore, we can close this session.
Okay. So I request the co-chair to, if you have any information to share.
Thank you, Professor.
Is there who is with me today? Yes.
Yes, sir. Co-chair is there, sir. He will be speaking.
Okay, fine.
I'm doing my job.
Okay,
so, in this session, all are learned speakers. First, Dr. Sanjay Nayak talk on habitat-specific lichen. He told us that Uttarakhand and Tamil Nadu is much more having the good habitat for the distribution of the lichen. About the eastern Himalaya, that is also good, having a nice habitat for the occurrence of the lichens. He has reported some new species and talk about the diversity of the lichen in India. Doctor, so there is one question that lichens are also pollution indicator. As I read some part about that, these lichens are the pollution indicator, particularly for the sulfur toxicity. Dr. Yogesh Joshi also presented lecture mainly emphasizing the host relationship that algae and fungi. But it is my note that he should also identify the algae host, either filamentous or some single-celled Nosta cannabina. He also reported some multiple association, algae, fungi, bacteria, virus also, and about 1% algal medicinal mushrooms reported from this lichen reported from the India. And he also reported some Perithecia pecnidia and endolichen and for the novel bioactive compounds. Dr. M.S. Reddy told us some new terms like litter fungi. I think this is new term, litter fungi, because endophytic fungi living in the living tissue, and when leaf become old, then it become saprophytic. And the another word he used, the agni fungi. So I doubt any fungi can survive at 100 degrees centigrade, but they produce some thermostable enzymes, and there are so many fungus also, thermophilic fungus like Itomium, Mycological, Mycological. They produce the thermostable enzymes. And Professor Murugesan, wood rotting fungi, wood decaying fungus about the Ganoderma, some mushrooms like polypores, and the floaters also. And about he told us about the polymeric compounds. So I thank MSI and the organizing secretary, Professor Sahi, and Professor Bhatt giving me the job. So thank you very much for being with us. Thank you very much.
Thank you, sir. Thank you very much. And it's a great pleasure that we shared this exercise of conducting these proceedings of this last day, first session. Thank you very much. And I thank the organizers for this wonderful arrangement. Thank you, sir. Thank you. I think we'll the tea session.
No tea session, sir. We will continue the session, sir.
Okay.
We are running behind the schedule.
On behalf of MSI Organizing Secretary, Department of Botany, Guru Ghasidas Vidyalaya, I would like to thankful all online and offline participants and dignitaries. This session is very wonderful session, and all speakers wonderful lecture था ये. अब मैं I would like to invite co-chairperson Professor R.V. Shukla sir. Please come on dais. Sir, come here. सर ये आप दे दीजिएगा सर्टिफिकेट. Thank you. And next, I would like to Dr. Yogesh Joshi sir come on stage. Please come, sir. Thank you, everyone. Now, tea break. है ना tea break? No. He is a friend. Yes.
We are going to arrange people. We can continue.
Okay. ये कहाँ है? Tea. We will continue next session. Coordinator, please, Dr. P.P. Roy, and reporter Dr. Atul Kumar Bhardwaj. Please come on. फोन करना पड़ेगा. एक मिनट फोन कर देता हूँ. They are online. ये तो ऑनलाइन है. Yes, Ravita. Are you going to present now?
तुम क्या हुआ? अच्छा Dr. Malagwe.
तो हम लोग ये शुरू कर लेते हैं सेशन, है ना? बाद में हम लोग बाद में बीच में जाके चाय पी के आ सकते हैं, है ना? वो यार हम
सारा चेयरपर्सन को चेयरपर्सन ऑनलाइन थे.
हाँ, दोनों ही ऑनलाइन है.
सारा एमिनेंट माइकोलॉजिस्ट
ओके, नो प्रॉब्लम.
नो प्रॉब्लम. कोई किसी को चाहिए था तो let them have and come. Because no, we are running short of time. It's problem. And most of the speakers were in honor. Most of the colleagues were in honor. Excuse me, and the team cannot speak out of here.
दोनों ही ऑनलाइन. हम लोग का काम और कुछ नहीं. ये
Sir, look, we are going to because it's getting late. certificate certificate வேற எழுதணும் சார். எனக்கு அதுக்காக ஆமா ஆமா ऑनलाइन है। नहीं 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 ये तो चली गई अमनदीप तो
Okay, good morning to all of you. It is my privilege and honor to invite Professor J. Shavita. Good morning, madam. That is a sectional editor, Kabaka MSI, and she is a professor in biotechnology in Bangalore University. I welcome you, ma'am, for chairing the session. In this, I also welcome Professor Dr. Selvam, former head of the Department of Botany and Microbiology, the Pushpam College, Tamil Nadu. I welcome you, sir.
Good morning, sir.
Good
morning.
Thank you. Good morning, sir. So as we are, now I am hand over this session to Chairperson Professor Savita and Dr. Selvam. Welcome.
Thank you.
Good morning, madam.
Thank you. Good morning.
Good morning.
Yeah, madam.
A kind request to all the presenters to keep up the time.
Hi. Other person. Vishwa. Yeah. तो नीचे करो नीचे करो Hello. Hello. Hello.
Yeah, we can hear you.
Yes, madam.
Yeah. Can I start, ma'am?
Yeah, we can hear you. Yeah, you can start.
Yeah. Thank you. And good afternoon, all of. Sorry, good morning, all of you. And I must thank MSI and for giving me this opportunity to share some of my research works in front of in front of you. And thanks for selecting my poor abstract for the Middle Age Trimalachara Young Scientist Award, and I must thank all of them. So I'm here to present my part of my research work that is entitled Taxonomy and Phylogeny of Wood Inhabiting polypores from Tamil Nadu. Actually, my earlier speaker, Professor K. Murugesan, made my job a little easier because he has clearly pointed out what are the polypores and how it has been economically useful to the world. And if you take the polypores or the wood rot fungi, but they have been generally called clumped under the common name polypores. But if you take the classification aspect, this polyporials order has been elevated and a rise in 1926 by Gorman. And that time he has placed only 10 families under it. And that time it was a very less report throughout the world. So only 10 families were available. And when they were investigating on the morphomicroscopic characters, they got able to, excuse me, can you please switch off these lights? And if they were analyzing the characters, then they could able to see a lot of variations. And here I have given some of the pictures of the hymeneal surface. So I'm here to present only the poroid polypores, but in spite of it you can find a lot of variations in the hymeneal surface among the various groups of the polypores. And not only this, and they do show a lot of variation in the morphological character also. But when you take the Indian context for the polypores, and many experts and eminent mycologists from northern parts of India and middle part of the India, they have worked extensively and they brought many new species under various families of the polypores. And when you come to the southern India, our eminent mycologist, the late Professor N. Nadarajan sir, has initiated this work. And we want to follow his footsteps, but we have not contributed like him. We have just done only a point, not 1% of Professor Nadarajan sir work. And I'd like to go a little bit about the order Polypores. Earlier, the order Polypores was called as the Aphilophores. That was a very common terminology has been used. Now it does not exist anymore. Now all of them has been classified under the class Agaricomycetes, and now the polypores, Aphilophores has been converted into polypores along with many sister taxo orders. And the polypores has been gaining more and more importance because of its many economic importance, in spite of its pathogenicity. If you take order polypores, they could able members of polypores. Some of them it can able to cause brown rot, and already Professor Murugesan has explained about it. And some of them can able to cause white rot. So they were causing a disease to the forest trees as well as to the avenue trees plus cash crops. In addition to that, many of the metabolites has been known for the promising agent which can cure many health issues. So it has been consumed by not the Asian peoples, and many of the products has been sold in the market. This is one aspect. And because of its various economic importance, and especially in the enzymes, and this polypores members, different members has been extensively studied by the mycologists. And for this aspect, what they have done is they started taking the information from the genome. So they have gone for a whole genome sequencing. Earlier, only phenorochetae was considered for whole genome sequencing. Now it has been extended. More than 50 whole genome sequencing has been done under the polypores alone. Maybe now somewhere in part of the world, some mycologists might have initiated the whole genome sequencing for the any member of the polypores. So the economic importance, the medicinal aspect, plus whole genome sequencing not only gave a lot of valid information about the polypores, but it keeps changing the polypores or the classification. So in 2013, the whole genomic classification has changed the classification of the polypores. So if you take the polypores, initially it was Aphilophores with 10 families. Now it is in 2013 it was with 13 family. In 2017 it was with 40 family. If you check the microbank now, it is with 64 family. Okay, so when we started, it is 1926. Now the age of the polypores is 94 or 96. Maybe in the next golden jubilee, I may present, we may any world, or you may add any new family so that it may reach a century. So coming to my taxonomic aspect, we have collected this polypores, members of polypores in the Tamil Nadu, and we have extensively studied their macromorphological characters. In addition to that, and some of the species were very difficult to identify. So what we have done is we have used the molecular DNA-based method. So for this aspect, we have been targeting the ITs plus LSU, the large ribosomal subunit. We have sequenced them and we have done the phylogenetic analysis based on the maximum likelihood and the Mr. Bayesian, which gives you the posterior probability of the clade. So, so some of the places where we have collected the polypores member, and this is from the most of my studies were confined with the eastern Ghats of the Tamil Nadu, and this is from one part, this Trivandrum, different reserve forest, and this is from Trichy, another reserve forest. It is called Patamalai and nearby area, and various reserve forests in that area. And this is from again Polyhill. This is Erka, and this is from Salem, the downhill of Kollimala, I can say. And this is from Kalroyan Hills, and this is the plain in and around Chennai. So we have collected nearly more than 300, but I can't able to present all here. I'm going to present only about the 150 isolates of polypores member. So when we study the polypores member, and for the student's point of view, so we have to observe all the Basidium meta characters, whether it is solitary or imbricate or clustered, effusively reflexed or resupinate. Then we also see whether it is having a shiny surface or it is having a spiny structure on the pileal surface. Plus, we also look the context, whether it is the same or the duplex. Then, definitely the poroid surface is very much important for the identification. That also as a valid character. Besides, we have to look into the various microanatomical structures. What type of hyphae is present? And if it is a sterile element, what type of sterile element is present or absent, whether any encrustation is present, if it is very meager or heavily encrusted. Besides, we also look for the basidiospore character, whether it is a thin wall, thick wall, what is the size and shape, please. So after finding out after studying the macromorphological characters, it is easy to discriminate some of the polypores members. So accordingly, we have classified them, and accordingly, we could able to identify those polypores with available monographs. But some of them were very difficult to identify. For those, we have used the molecular approach, that is ITS and LSU. So now, after this identification, we could able to come to a conclusion that all of the members could able to fall under the various families. So 150 polypores member, it has been falling under the Formitopsidaceae. This Formitopsidaceae is predominantly of brown rot fungi. It's having a lot of economical value, and we have found nearly 4 species from this Formitopsidaceae with one new int. Ma'am, can you hear me? Am I audible?
Yeah, I can hear you.
Hello.
Yeah, I can hear.
Yes, ma'am. Yes, ma'am.
Yeah, thank you, ma'am. Thank you. And the next major group of the polypodactyl and it has caused rot disease to oil palm. It was a huge loss for the Southeast Asian country and even in some of the coconut farms in India. But in spite of that, not all the species are pathogen, and we could able to identify nearly 6 species, and some of them we couldn't able to discriminate. So we have approached DNA-based method. Then the next one is the Incrustoporiaceae with 2 genera. One is a new entry to the world, and the next family is the Meruliaceae with 2 entries, known species. The next one is the Irpiaceae with 1 new entry to the world, that is a Trematopsis. The next one is the Phanerochaetaceae with 2 genera, Oxychaetae cervinogilva and Phalaebiopsis castrinae, and 1 more new species from the Phalaebiopsis. The next major family that falls in our collection is the Polyporaceae. So in our collection, the Polyporaceae is very dominant. We could able to identify nearly 20 genera, and most of them were new to the world. I will be talking about it little later. So these are the different genera with a species from Polyporaceae family. So there were nearly 20 genera under the Polyporaceae alone. So these are the different collections of our study. The first four belong to the Formitopsidae, then the rest are from the Ganodermataceae. So you can see a lot of variations among them. The lucidum is a very common, aplanatum and gyposum are also very common. So Epiaceae, Skeletocutus is from Incrustoporaceae and Flavodon flavus, Vetrioporus dichorus, and Philibiopsis from Phanerochetaceae, and Philibiopsis Tramatopsis, Oxychaetae cervinogilva, Serina agarota, and these are the members of Polyporaceae, and all of them are the members of Polyporaceae, and these are also. So, coming to the Formitopsidaceae family, we have got four, and we could able to go for a molecular identification because when we are approaching this Rhodoformitopsis phi, the characters were not matching with the monograph. So ultimately, we have ended up with molecular taxonomy. So our strain was found to be Rhodoformitopsis phi. The next one is the Brunio Saparus malicola, sorry. And the next one is a new entry to the world. And if you see the combined data set phylogenetic analysis, both ML and the Bayesian, and the basal clades were not resolved. And besides this, there were a lot of variations in the morpho microscopic characters also. So we have been further, already we have done IS and LSU for the all new entry. In spite of it, we need to go for some protein coding gene. Always RNA polymerase 2 has been reported to be the valid protein coding gene for the molecular taxonomy aspect. So now we are working on the amplification of RNA polymerase 2 for all the new entries of our study so that we can proceed for publication. So this is the new entry from the Formitopsidaceae family. So these were the known species from the Formitopsidaceae. You can see the hymeneal surface and the microscopic illustration, and Dadroniella scutellata, Rhodoformitopsis phi. And the next one is the Ganodermataceae. In Ganodermataceae, we have a known species Aplanatum, Gyposum, Tropicum, and Lucidum, Resinaceum. Besides, and here you can see some of the collections were standing alone in the phylogenetic tree. And Ganoderma species 1 and species 2 and species 3. And they are showing a lot of variation in the spore size and the shape besides. And the molecular data also giving a hand so that they were standing out. So we are working on this further. And these were the microscopic illustration of Aplanatum, Gyposum, Lucidum, Philippine, Resinaceum, very common one. And this is a Tropicum again. Suge, okay. So these were the known species I have given. I haven't given the new entries here. I haven't given the microscopic illustration of new entries here for any polypose member. So since we are working on it, I have just avoided. So if you see the phylogenetic analysis of Epiaceae and Merulaceae, we have nearly 3 members. One is the Vitrioporus dichorus and Tramatopsis species and flavored on flavors. If you see Vitrioporus and flavored on flavors, they were falling under the Merulaceae family. And this Tramatopsis was earlier, it was placed under the Polyporaceae. The extensive molecular data was posted to Epiaceae. And if you see this phylogenetically, you can find one Merulaceae member, and at the end of the bottom of the tree is having another Merulaceae member, and in between you can find one Epiaceae member. So this is creating a lot of confusion again whether all Epiaceae member are monophyletic or polyphyletic. So you can find Glucopore and dichorus. So when we are starting our work, we have thought our collection is the Glioporus dichorus. When we are refining our study further, but we could able to see that this is a newly reported genera Vetrificus. So again, we are working on this with the additional protein coding gene. And this is a Incrustoporus a member, Kelitocutis amorpha, and their microscopic illustration. This is a flavor belongs to the Meruliaceae. Vishwavidyalaya chorus. And the next one is from the Phenodrochelima. The Phenodrochelima is Oxygetes ovina gilva, which is very strong, irrespective of the any part of the reserve forest.
Is there any problem with the signal?
Yes, ma'am. Here we got disconnected. We are sorry. And again, we joined the meeting. We will be sharing the slide, ma'am.
Okay.
Network issue, ma'am. Yes. They were sharing the slides, please. Here they have to share the slides. Ma'am, in which slide we have left? I am not sure about it.
You were telling about Phomopsis, no?
Phomopsis is the first, ma'am. From that time.
I think it was Trematopsis something. Yeah.
Okay, thank you. Thank you. I will continue from there. Yes. So we were working on this Trematopsis. I'm going to continue from here. Then it is a Skeletocutis, member of Incrustoporaceae.
You have to go for slideshow, I think.
Yes.
Now fine.
Ma'am, it is in slideshow, ma'am.
Now fine. Yeah.
Actually, no, here there is a problem. We couldn't be able to move to the slideshow. Can we present like this?
I think that should be okay.
Okay, thank you, ma'am. And so this is the Phlebodon flowers from Meruliaceae family. Ma'am, excuse me, ma'am, it has got hanged, please. Again, we are moving up. Huh? Hello.
Yeah.
Ma'am, again, it is not responding.
It is hanging up.
Kindly bear with us. Yes, ma'am. The window is not responding, ma'am. That is actually. शेयरिंग चल रही है ना? हाँ.
Can't be rectified.
Yes. No. Ma'am, actually,
Actually,
present not
voice also is breaking. Sir, Panir Selvam, sir, can you hear?
Madam?
Sir, can you hear, sir?
Yes, madam.
But I don't hear.
No, the voice also is breaking.
Yes.
Yes.
Yeah.
It is breaking.
Voice is breaking. For the past 2 or 3 minutes, it is not functioning. Audio is not clear.
Ma'am, we are trying.
Your voice is breaking, ma'am. Can you ask someone to rectify this?
Sorry, ma'am. They were working on it.
Okay, we will wait.
But still, the same problem is right. Okay. Ma'am, actually, it is, if I make it the presentation mode, it is giving a lot of trouble. Can I present like this?
Yeah, carry on.
Okay. Okay, in the slides you can find out, you can see the phylogenetic relationship of the two Phanerochetaceae member. One is the Oxychaetes cervinogilba. This one is Oxychaetes cervinogilba. The another here is the Viridium meta character. And this Oxychaetes cervinogilba we have collected in all the reserve forests of Eastern Ghats. And the next member is the Phalabiopsis species. And this Phalabiopsis species is very close, it is having a similar morphology, just like that of the Phalabiopsis griseoflaviensis, but they are showing a lot of variations in the spore. The spore length is more rather than the size, and it has been, this unique feature has been substantiated by the molecular character also. In ITS and LC, you can see the branch length of Phalabiopsis new species and the related taxa. So we are ultimately end up, this could be the new species. So we are working on the additional protein characters. Apart from this, there is a known species of Phalabiopsis, that is Ghasidas, and their microscopic illustration. And the next one is the Polypotaceae member. This is such a huge tree, and we have been made into short parts, so that it is easy for us to know what is there and how it has been placed and where it has been placed. It is in case of Polypotaceae member, there were 20 genera has been found out from different parts of reserve forest of Tamil Nadu. The first one is the Cellularia genus, and the next one is the Cubamycetes. This is also okay, and Cubamycetes curensis and Cubamycetes lactinis. And Cubamycetes is well resolved. result. And the next one is the gycometers. Gycometers is into the as well as the microscopical character. Yeah. Movie. Okay. Okay. This one, 12. And the most of the statistical support. Even we could able to find out one new entry, and which is still again clustering with a capita, but with less variation. We want to find out is there any capita or not. So for that, we are working with the other additional genes. And another one is the polyporous dermosus pallus. I will finish it off. Because of the all this problem, I couldn't able to make it up. Sorry. And the next one is the Finalia. And again, we have one new entry to the Finalia, which is close to the Finalia cystidiata. Another new entry, Finalia, is close to the Gallica, but they show a lot of variation in the morphological character. And the DNA-based sequences are also showing a lot of difference. So it is not well resolved. In fact, the other one is the Exoconia. Another one genus is the Earliella scabrosa. Another important new entry is the Mechaporoporia. Yeah. Here slides are not. Then microporous and many species of Traumatis and two new entries of Trisaptum, please, and one Pycnoporous Saginesis. Please, move the slide. Okay. Then entry of Polyporia and additional new species from Polyporous. And these were the some of the members of Polyporaceae and their microscopic illustration. I'll rush because we are out of time. Coriolepsis rumosa, next. Coriolepsis strogi, next. Cubophysys latineus. Cubophysys Finalia aspera, Exoconia hita, Exoconia tenuis, Lentinus, next one, Lentinus, Microsporus vaniscus, Microsporus xanthopus, Magnoporus, Polyporous grammatopolus. Make it fast. And some of the Ramses we could able to identify. And this is the Tephora, Tricapsula. And I have just, please allow me to present final two slides. If you see the diversity of the Polyporaceae in eastern Ghats of Tamil Nadu, and the members of Polyporaceae were dominant. Polyporaceae were dominant, followed by the Formitopsaceae and Meruliaceae, whereas other families are having very less number of genera. And when it comes to the genera of Polyporaceae member, and the and further we will be doing phylogenetic analysis individually with the combined data set before publishing it. And in the next MSI meet, we may come up with more new entries with the species rate And in this regard, I'm really sorry for the inconvenience created. And thanks for your patience. I would like to thank our chair to permit me to present. And I also thank the MSI for giving me this opportunity to present my research findings. And I thank the CAS and Botany for allowing me to carry out this work. I thank the RUSA and DSC for the financial support. I thank my students for all this contribution. Thank you so much.
The presentation is open for discussion. If any one or two questions are there, it is welcome. Malarvedi, I have to appreciate you for the very
thank you, ma'am.
Yeah, the illustration what you have given from the natural condition. About,
thank you, ma'am.
Yeah.
Thank you, ma'am.
Malarvedi ma'am, nice presentation. I have mentioned very details about the polypores. Whether the polypores are host specific or it can colonize any type of substratum.
Sir, as far as our study is concerned, we couldn't find any host specificity, sir. If you see the traumatis, cubomyces, and Coriolepsis, and they are saprophytes. Even though they are cause the white rot disease, but we have found as the saprophytes. But Ganoderma is the showing some kind of host specificity. That's what the literature is. I don't find any host specificity.
Thank you, madam.
Thank you, sir.
Malarvedi, can I talk? Can I ask you one? Yeah.
Yes, please.
Actually, I wanted to know. There is a mention that they change their mode of nutrition. Like they may go into saprophytes and sometimes parasite and sometimes even mycorrhizal. How true is it for the polypores?
Yes.
Yeah. How true is it for the polypores? I mean, is it seen in the forest? Yeah.
Yes, ma'am. Actually, no, the Ganoderma is reported to be the pathogen.
Yeah. But do they change their mode of nutrition at times when the host is not available?
There is a very beautiful paper that we published. If I find the paper,
yeah, sure. I would like to.
I would like to say only one thing. And polypores, they exist as maybe a symbiotic relationship. Some are symbiotic pathogenesis.
Symbiotic pathogen.
Yes, that is a very interesting factor. If you take the Ganoderma and it causes a white rot infection, if it lives in the forest, the spore will be million in size numbers.
Yeah.
And each individual spore is a pathogen.
Yeah.
But the whole forest is not devastated by the Ganoderma. There is a kind of relation exists between the Ganoderma and the host tree and getting all the nutrients from the host tree, cellular space.
We may not be giving anything in return.
The tree has been protected. Yes. The Ganoderma is getting a substratum. The tree never allowed the Ganoderma to penetrate because it is being sublimating the sugar in the extracellular space. There are many sweet transporters involved in this.
Right. That interaction could be studied further. It would be very interesting. Yeah. Yeah. Again frozen.
Yes,
Hello,
yes.
can you hear
We
me?
studied beach.
Yeah.
How answers they are being
My God, the connection has gone again, I suppose.
I will send you.
Yeah, we can't
Thank
hear
you.
you, Mother. Yeah.
For
This is
this.
very I'll talk to you. I'll talk to you later. No problem.
Yeah, please.
We will get in touch. Yeah. We'll get in touch. Yeah. Thank you so much.
Is there any other question?
I really can't hear you properly. I'll get in touch with you personally. No problem.
I request the participants to mute their mic, but from somewhere the echo is coming. Participants has to open the two window. That's why the echo is coming.
Sorry?
Any other question?
Could you hear?
Yes, please.
Yeah. I couldn't hear your explanation, so I'll get in touch with you personally. Maybe I can sort it out later.
So sorry, there was some problem. I think there was signal problem. So
yeah.
Thank you for understanding the condition.
Very nice presentation. Yeah.
Please mute it.
So thank you, Dr. Malarvedi. Can you hear me? Hello? Hello?
Thank you. And so for inconvenience. Hello.
Hello? Can you hear me?
Yes, madam, I can hear you. Can you hear me? From our side, that is a problem, I think.
Yeah,
That's why
there
they
is
couldn't able to
some lot of disturbances there. Thank you so much, Dr. Malarvedi.
Thank you, ma'am. Thank you so much. Sorry for the inconvenience. Thank you. Thank you.
Okay. I request the organizer to carry on with the other speaker. Hello? Hello?
Hello, madam. The next.
Yeah. Shall we pass on to the next speaker? Hello?
Hello. Can you hear me, ma'am?
Yeah, I can hear you.
Hello.
Can you hear me? Can you hear me?
Yes, sir. Yes. Yes, ma'am.
Yeah.
I'm going to
pass on to the next speaker, please.
Mamta Patra Shahi. The enzyme profiling LD of the fungal isolate for the biodegradation of polythene to Chhattisgarh region. Yes, yes. Thank you. Yes, yes, yes. There's no problem, ma'am. Excuse me, ma'am. Can you hear me, ma'am? Hello? The coach are free available. Excuse me. The co-chair person is available or not? Hello?
Yeah, I can hear you.
Okay. Okay. So good morning to all of you, the member of the dais, the chairperson, and all the delegates who are joining us in offline mode as well as online mode. Today I'm going to present a design profiling of some fungal isolates which I have isolated from Chhattisgarh region for study of the biodegradation for the polythene. And next, please. As we all know that the plastic has been the global issue, become as it is under uses in various parts, that is the transportation, medicine, electronics, building and construction, personal protection. But my focus is on the packaging material, that is the polythene, which is one of the most polluted, not only from the ground, but also from the societal. Next. Now you can see that packaging material, which is primarily used polythene material, and specifically the LDP, that is the linear LDP polythene, that is approximately 35% including. Next. Now you can see that the plastic has been now become the not only for the garbage issue as well as for the solid waste management issue. Next. It also kills so many biodiversity individuals, or you can say that the plants as well as animals. And in some recent reports, the microbes are also has been affected, because now we have categorized the polythene in various level of the size of the polythene. That is up to now up to nano range. We have got the but also for the vitro stage. And as most recently, there are some alternatives are also available, being as a biodegradable, but the strength is not comparable. The strength of the polythene is the synthetic one, which is not comparable to the biodegradable alternative of the polythene. So that is why, as well as the whatever the present scenario of the handling the garbage which is produced by the polythene, we have to go for the further vitro study also. Then when after vitro study, we go for the vivo study. Next. So I focus it here. Although there are so many types of the plastics are there, but I focus here only the polyethylene, initially the LD. Next. So we have isolated and screen the plastic debris, especially the polythene, that is the linear density polythene film, has been collected from various regions of Bilaspur market, and then we have sterilized it in various techniques. Primarily, we do the ethanol, which is visible, and then sample collected. Next. So we have collected from Raipur region, Durg region, Rajim, Ratanpur, Maya Mandir, which is one of the most famous mandir, and the Girisaban and the Pangal. All these regions, I have not here focused that we have selected the samples from the litter or the garbage cases, the soil sample, or not on other type of sample. Only there we dug the plant, we selected the overall surface of the soil. And then next. That's so all vegetables. I focus with the which are going to protect. Although I was studied of next, these are the species method, 2 of 57 markup and the dilation method. And then further we have next verified it for the further study. Now this is the basic study, that is the problem is to tackle the polythene is one of the important issue, that is it is totally non-biodegradable in nature. Why? Because it is highly hydrophobic in nature, and the biodegradability of any microorganism is the first step to break out the hydrophobicity of the surface of the synthetic material. So that is why we are not going to, or very much have easily to tackle this problem to degrade the polythene. Why? Because it is highly highly hydrophobic in nature. So that is why I have selected those. Then I further screen for these fungal isolates that they have some adaptability or not over the fungal polythene film. So you can see next back. Yes, you can see that I have made the nutrient barrier, which is without any and fungal isolates. They have see whether they have some ability to touch it not, in general language, touch it or not. That means if there is some that is the fungus is going over the polythene. So that is why screening of the fungal isolates, we have screened these that they have some ability to grow over the polythene in nature. So because the polythene is a hydrocarbon in nature, is mediated not there. So that means when growth is there, that it requires source only the carbon source here. So before microorganisms further study for the enzyme profiling for specific type of enzyme, I have selected 3 group of next for the 3 group of peroxidase enzyme. As the peroxidase enzymes are highly involved in the pollutant degradation, and mostly the pollutants are in presently the hydrocarbon nature. Polythene itself, it is a very highly hydrocarbon, very much resistant. That means the bond between the hydrocarbon are not easily to break by the microorganism. And we all, not only from from all over the world, we have tried to break the bond, and that is why the easily and this, as we know that outside the fungal are doing activity in nature from outside of the nature. That means they extract something, and then this extraction react with the material which you have studied, and then after the reaction it shows the activity. So similarly in this case, I have selected from those microorganisms which have some affinity to grow over the polythene, and then from these fungal isolates we have selected those fungal isolates which are also producing the peroxidase enzyme. This actually, hello, these enzymes are actually having very much high ability to degrade the pollutants, majorly the hydrocarbon pollutants. So that is why I have also screened these isolates for further screen for the lactase, and then lignin peroxidase and the manganese peroxidase enzyme by positive those fungi which I found to be the positive during my qualitative analysis, not the quantity, because my focus is on biodegradation, not the quantification. Then peroxidase enzymes are also major environment pollutants also degraded by these peroxidases. Next, you can see that by the qualitative screening, which I have done that by D'Souza et al. 2006 method, and you can see the zone of coloration, which showing the positive of the lactase E production. Next, LIP production. Actually, I have some modification is in Sivakami et al. 2012 and et al. Atala 2010. That the lignin, I have isolated this lignin from the plant bark and then standardized it out, purified it. So that is why you can see that there is no dark plate is here. Because the lignin is very much low in production. That means the LIP enzyme is very much low in production. Then you can see the zone of. So that is why I have quantified it out very much low. So that is why the only single microorganism I found that producing the LIP enzyme production. So there is some modification also in the medium formation away from the Sivakami and et al. Next. This is the manganese peroxidase. It is simple method by Kawahara et al. 34. And you can see the zone of oxidation. Next. So here I focus here that although these peroxidase enzymes are involved in degradation of pollutants, but we cannot assign here, as you can say that from these fungal isolates, all are found to be mostly, that is the MNP positive. Only 4 are found to be lactase positive, and only 1 have been found of the LIP positive. But you can see that the single microorganism or the fungal isolate, we found that producing all 3 types of peroxidase enzymes. So I cannot focus it out that which we have selected. So that is why I have selected all the microorganisms which have, whether they are producing the MNP positive or the lactase positive or the LIP positive, and further classify it out. Whether there is some correlation is not, whether the ability of the degradation with the presence of this peroxidase enzyme. Next. So after the screening of the peroxidase enzymes, we screen it out for the polythene degradation. This is by the simple method, that is by Dylan et al., and for the qualified by the et al. Method, and by weight reduction method. Although there are so many other technical methods are available, which I have also done, but presently, due to my primary data, I have first to do this because it is primary. Next. So here you can see that the TCM1, it is found to be most effective. Now you can correlate back. 2 slide back. Yes. You can see that this fungi we have isolated is not producing the LIP. Also, it is producing these 2 enzymes and found to be one of the most effective one. Next. Next, and it found to be 13.1%. Actually, I focused it out, although the biodegradability study had been done, but this is the first time which I have done without any pre-treatment of the polythene. That is, in natural condition, there is the oxidation of the polythene is going on, and we can study it out. But in vitro study, without doing any, it is the raw material which I have done it out without any pre-treatment. Pre-treatment means whether you have some chemical treatment is there or some UV treatment is there, as the sun is one of the most oxidative and its photo-oxidation is there. So there is no any pre-treatment is there. Still, we found that without any pre-treatment, this fungal isolate found to be 13.1% of degradation with this simple method. Next. So first, next. Then we do also for this isolate for the spectroscopic method. Actually, the spectroscopic method we do here for analysis of the treated polythene, whether it is showing any oxidation state or not. Because in method of biodegradation, we have standardized the method where there is no carbon source, only the polythene used as a carbon source. So that is why if there is activity is there in the microorganism, in the fungal isolates, then it should be some activity on the polythene. That means they have producing something which degrades some level the polythene, and then it shows the oxidation state. As you can see next, as you can say that this is the oxidation is marked, and there is a stretch is there. Also, it is very much minute, but it gives us a very high hope for further treatment. If we treated it out, maybe it is increased. So because oxidation stretch is there. So next, this stretch actually in the aldehyde form. So there is a stretch, that means there is oxidation is on the polythene. That is chemical analysis showing by the FTIR method. Next. So we have also next, after FTIR, next back. We have also doing the biofilm analysis as well as the visual observation, which is the first observation by a scientist with hand, that whether there is any change from the very fresh material to the polythene, that there is any changes or not. But you can see that although these microorganisms are producing different type of enzymes, they are not showing any type of significant cracks on the physical changes, which is the first sign, or roughness, then the color change. Only this method, this DOC found to be the roughness. When I touched it out, it found to be rough. Okay, so that means there is some changes. We have to further study it out. Then, although the cracks are there, but during my analysis of the SM analysis, these cracks are not very much clear. So that is why I have heard it out that it is not very significant. But looking it, that there is some crack. It has been changed slightly, become the slightly yellowish in nature. Maybe this yellowishness is due to some other region which I have not yet studied, because my focus is that whether it is degraded or not. Next, then the scanning electron microscopy, it shows, you can see that film is there and the fungal hyphae is also here after the treatment. So this is also the very good sign that there is some of the breaking of hydrophobicity of the polythene by this strain. Next, that is showing the crystallinity has been changed or not, and you see that crystallinity was also the temperature has been changed from this from before it got this to this. I can say that this is the treated one. Next, then this is one of the untreated one. So back to the next. Back. Back. So after DSC analysis, that is very which is actually crystallinity is changed on the which has, and the crystallinity has been changed. Next. Now I have also studied that there is in media there is any pH change or not, and the pH we found that from very beginning to after 2 months only the 6.2 has been from starting it is 7. That means there is some activity inside. Only the carbon source is polythene. So that is why we can hope for this microorganism, which I have done the molecular analysis of the microorganism, but I have not studied here because the study is going on. Next. So this is my conclusion is that I have simply studied, this is my primary data. I have simply studied isolate first microorganism, then we tested it out for the peroxidase production, then we tested for its biodegradability, and then we tested that whether there is any physical as well as the chemical changes has been done by this isolate on the polythene. So we can further it out that from next it is going on. That is first we have done the molecular analysis and going to submit in NCBI. So that is why I am not presenting here the name of the microorganism. Then also I have done to enhance the biodegradability of the microorganism. I have also studied from this focus and some other fungal isolates. So the whether the fungal consortium can be helpful to improve the biodegradability of the polythene. So the study is going on. Next, I have also used that the carbon source as different type of plastics also, not only in the polythene but also the SDP, LLDP. That is the different grades of polythene, and frequently we are using. Not a single person here, I think, including who are not using the polythene. And then the last is approaching, which is also being studying on, that is from lab to land, because in vitro studied it found to be may be effective, but when we apply it in lab to land, maybe we get it. So we have to categorize it out, and we are further doing it out that whether there is hope for specific enzymes isolate from the different screening of the enzymes, not only the peroxidase but also different type of enzymes from that isolate, which may be helpful for the degradation of polythene. Up to further study. Next. So this is the pollution. Although hope from the microbes are there, that they are eco-friendly, eco-safe. These terms you have heard from so many years. But biodegradability, of the using of that microorganism in lab to land, that means the safety gets from the microorganism in this particular issue, because the polythene is not the lab study, it is a field study, and you have find out the microorganism which is highly infectious and found to be very effective to control the polythene. You cannot simply pour it out. So that is why there are so many criteria, because we are going for the from lab to society. So that is why the further it is going on. Next. So this is all about, this is my primary data, and thank you to all. Thank you, member of the jury and DICE, member of the DICE. Thank you.
Thank you, Dr. Mamta.
Thank you, ma'am.
Yeah, it is open for discussion.
Madam,
yes,
Mamta Patra, my sincere appreciation for the nice presentation.
Thank you, sir. Thank you. Thank you very much, sir.
This is the need of the hour. You have taken a very interesting topic. Just I have only one question. What is the size of the polythene bag you have subjected for the degradation experiments?
Sir,
I mean, micron.
Yes, sir. Actually, I have standardized it out from 1 to 1. 1 to 1, that means 1 centimeter to 1 centimeter squares. Then for the further study, in 5 ml media, that is MNS media, mineral salt media, without any carbon source, and the carbon source is that. That means up to 1 gram, we can study it out, but the present here to standardize that after sterilization of the polythene, we have a 1 to 1 square shape. Cut it out in a sterilized condition.
Good, madam. Thank you.
Thank you, sir. Yes. Anything?
Dr. Mamta?
Yes, ma'am.
You have in future plan you have written to enhance the biodegradability capacity of the plastic by microbes. So what are all your plans?
Actually, ma'am, I have done the project on find the project on this also from DST,
and the further is going on. That means the focus is on uh, to standardize that when we use the general method means we using the MNSP method, media, that is the general media. To enhance that, it should be in solid media, and there is no report to study it in solid media. So I have tried to develop, almost have been developed the solid media for the degradation studied. And the problem is that when we develop the solid media, so for the solid media, there will be any carbon source. And the problem that I focus here, that the somewhat inert material I have used as a uh, carbon source. And the problem, not only the inert material, but the problem is that it is not dissolved by even some of the very harsh chemicals. So I have standardized some method to dissolve it out in bio chemicals, which is going to publication. So that is why I have not. It is my primary data. So actually, I have also studied that solid media, which is biodegradable media. So that is why if we put it anyhow, uh, the polythene, and because the enzyme durability, if we found that that means in China it is found that some polythene pet degrading enzymes are there, but for the problem of the enzyme, that it is fine to be studied in lab condition, but when we go for the land study, the condition of the enzymes to be as an effective product to destroy any pollutant is very much high costly effective. So protect it out to the enzyme. So that is why we have to focus our mind not only for the lab study, but though in general conditions. That is why I have opted the polythene as such from the market. Not only from, I have purchased it from Sigma and all. Why? Because the general people are using the polythene from the market, and we have to tackle these polythene from the garbage, because the heaps of the polythenes are there. So if we found some these capability, that means yes, ma'am. Thank you.
So thank you very much for the nice presentation. So we will move on to the next presenter.
What is this one for us speaking? No. Yes. Yeah. It is not. Yeah, it is not. Okay. MSI. Open it. It will be. Yeah. This one. Oh, this one. Only 10 minutes. So good morning. So I am Dr. M. Kandaswamy, working as Assistant Professor of Botany at Kungu College of Arts and Science at Karur, Tamil Nadu. Good morning to the
the reporters, chairs, and co-chair, and faculty members. The title of the topic is Algae Associated for Textile Production. So Textile or Package Textile is a terpene lactam. Textile is highly efficient for and a broad spectrum of natural anti-cancer drug. It is used for the treatment of malignancies such as breast, lung, colon, and head and neck cancer. Taxol is found in very low concentration in the bark of the cactus tree to protect limited resource and lowering the cost of their drug therapy. The search of new source of Taxol is always demand. Okay, so endophytic fungus is a efficient and good source for the production of numerous compounds which is used in the medical field. So, so in particular, the microbial fermentation showed that the initiation and identification of Taxol producing endophytic fungus, which would be very prospective method and adequate way of for the production of large amount of Taxol. So the main objective of the study is to identify the Taxol producing endophytic fungus associated with what is called the marine algae, which is called the seaweeds. So the collection of seaweeds. The seaweeds were collected from different seashore of Kanyakumari, Muttam, Arogyabram, Vattakotai, Rameshwaram, and Mandapam along the coast of the Tamil Nadu. Isolation of so isolation of fungus. So the medium used for isolation of Taxol producing endophytic fungus is what is called the potato textureous agar, supplemented with 1% of chlorophyll antibiotic and 0.1% of the paclitaxel, which is used in the treatment of the cancer. The the plates were incubated at room temperature while they are producing the fungus, which is emerges from the segments. Okay, after 24 to 48 days, the growing fungus were subcultured for the production of production of Taxol. Okay, so the for Taxol producing the medium is potato textose broth supplemented with chloramphenicol and Taxol, and after the for 72 days, 22 hours, the medium is filtered and Taxol is extracted with methanol. Okay, so the crude extract and it is dried. The crude extract is used for identifying the Taxol. The methods by which we are identifying the Taxol is silica TLC analysis. Here we using the silica gel as a solid phase, and the solvent system is methanol and chloroform 7:1 ratio, and we are and the purified compound is given with MK University to identify whether it's a Taxol or a things by using some techniques like UV spectrum and HPLC analysis. So based on the morphological characteristic features and the microscopic studies, the algae, the seaweeds which are producing Taxol producing fungus is what is called Aspergillus terrace, isolated from Ketomorpha, collected from the place of Mandapam of Tamil Nadu, and area species isolated from Tadaina, which is collected from the Muttam, which is nearer to the Kanyakumari. The yield of the Taxol product is obtained from potato textose broth medium. Okay, so and then we are extracting that and identifying the shown is the Taxol by using the TLC method. And okay, so by the the right hand one is what is called the curviliaria, which shows the the taxol production, and the left hand side one is what is called the aspergillus, and the lower slide one is what is called the UV spectrum, and then it is identification of fungal taxol. Okay, so it is HPTLC method, HPLC method. So, based on the findings of the present study, suggested that the Aspergillus and Curviliaria species is an excellent source for the production of taxol, and it may become a highly potent strain on commercial scale. So, we did the experiment only on qualitative basis. So, we are not quantifying the how much the Aspergillus and Curviliaria species producing the taxol. That's all. So I thank for our college administrative committee for providing a chance to present the paper, and also MSI for giving a chance to attend the conference and presenting the paper. Thank you.
Thank you, Dr. Kandasamy.
Thank you, ma'am.
Yeah, anyone has a question?
Sir, Mr. Kandasamy, sir. Hello.
Solunga, sir. Tell me, sir.
Yes, I am Paneer Selvam. Mr. Kandasamy, sir.
I know, sir.
I am very glad to see your nice presentation.
Thank you.
Out of 10 algae, which one contains maximum number of endophytic fungi?
Sir, we are not quantifying that how much endophytic fungus is there.
Okay.
So we only using the taxol producing endophytic fungi that we are using only. We are using a taxol in the media, taxol in the media. So that organism which are degrading, the taxol only grow in the medium. So we are not quantifying that.
Okay. Thank you, Professor. Thank you.
Thank you, sir. Thank you.
Thank you, Dr. Kandasamy.
Is Nagaraj sir is there? Hello? No, sir. I think he's not there. We can proceed. Yes. No, not available.
Nagaraju sir, are you present at here? I think so. He is not present. Sir.
Hello. 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 Hello.
Hello.
Chairman.
Hello.
Savita ma'am.
Yes.
Ma'am, actually, Dr. Nagaraj is not available in online, ma'am.
Okay.
already Avneet Singh and Amandeep have presented.
Okay.
And Mr. Sharma, OFMA02 is not available here.
Okay. So you can pass on to the next person.
Ma'am, it is already over, ma'am. That's all the list, ma'am.
Oh, that's all.
Only 8.
So others,
only 8
have,
presentation.
Okay, others have not. Is not participating.
Yes, ma'am. Yes.
Okay. So just we will sum up.
Avneet, ma'am, excuse me, Avneet Singh and Amandeep Kaur, they have presented yesterday because they are having flight today morning, so they left.
Okay.
They have already presented yesterday.
Okay.
And Mr. Nagaraju, Dr. Nagaraju and Kamlesh Shukla and Sharma, they didn't turn up.
Okay, no problem. Yeah.
Ma'am, actually, yes, ma'am.
Please carry on.
Ma'am, you can end the session, ma'am.
Yeah. Okay.
Thank you, ma'am.
Okay. I thank profusely the organizers for giving me an opportunity to be the chairperson of this session. And I think there were only 3 presenters presented by Dr. Malarvili, Dr. Mamta, and Dr. Kandasamy. So Dr. Malarvili gave a very good, the overview of what are all the polyporous organisms are there in South India, and Mamta and Kandasamy, they have given a overview of what are all the degradation aspect of fungi along with algae and things like that. I congratulate all the presenters who have participated and then presented their findings. And now I will pass it on to Dr. Panneerselvam to end the session.
Very good afternoon. Very good afternoon to all. Hello, can I able to hear, madam? Can you able
yes,
to hear?
I can hear you.
Okay, madam. Very good afternoon to all. So in session 10, parallel session 1, totally 3 papers were presented by middle-aged faculties and scientists. So all the papers were excellent and their mode of presentation is highly appreciable. We thank the coordinator, Dr. P.P. Roy, rapporteur, Dr. Atul Kumar, chairperson, Professor J. Savita, organizing secretary, Dr. Sushil Kumar Sahi, MSI secretary, Dr. N. Raman, MSI president. So all the staff members of Guru Ghasidas Vishwavidyalaya Bilaspur for the excellent cooperation. My sincere thanks and appreciation to all the participants of MSI. Thank you for one and all.
Thank you, sir.
Thank you, sir.
Thank you very much.
Thank you so much.
Thank you, madam. Thank you, sir.
For bearing with us with the technical difficulties. Thank you, madam. Thank you very much.
Thank you.
मीटिंग तो होती है ना।